Lohar sir.
Yes, sir, I'm present.
May we start?
Yes.
सांगोला तालुका शेतकरी शिक्षण प्रसारक मंडळ सांगोलाच डॉक्टर गणपतराव देशमुख महाविद्यालय सांगोला organizing 2 days international e-conference on recent trends in nanomaterials and its applications. Respected chairpersons, distinguished resource persons, honorable guests, esteemed colleagues, dear researchers, participants and students, a very good morning to one and all. On behalf of सांगोला तालुका शेतकरी शिक्षण प्रसारक मंडळ सांगोला, डॉक्टर गणपतराव देशमुख महाविद्यालय सांगोला, the Department of Physics and the Internal Quality Assurance Cell, it gives me immense pleasure to warmly welcome you all to the second day of the International E-Conference on recent trends in nanomaterials and its applications, RTNA 2026. Yesterday's inaugural session and invited talks were highly enriching and intellectually stimulating. The insightful keynote address, expert lectures, and active discussion laid a strong foundation for meaningful academic exchange. We are confident that the deliberation today will further strengthen our understanding of emerging research trends and practical applications in the field of nanomaterials. Today's program features eminent resource persons from reputed institutions who will share their valuable knowledge and research experiences. Their contribution will inspire young researchers and motivate participants to explore innovative ideas and interdisciplinary approaches. We are deeply grateful to Punyashlok Aili Devi Holkar, Solapur University, Solapur, for sponsoring and supporting this e-conference. I also extend my sincere thanks to all chairpersons, speakers, coordinators, organizing committee members, and participants for their continued cooperation and enthusiastic participation. I take this opportunity to welcome all our resource persons and chairpersons of today's session. I request all participants to actively engage in the discussion to make this academic event truly fruitful. Once again, I warmly welcome you all to this 2 days RTNA 2026 and wish everyone a successful and informative and inspiring day ahead. Now, I would like to invite today's chairperson, Dr. Surendra Sinde, to chair the session. And also, I would like to invite an eminent personality and young scientist, Dr. Gaurav Lohar, as a resource person for this session. Thank you. Over to you, Surendra sir.
Thank you, sir. Good morning, everyone. As the chairperson of this session, it's my honor to welcome our guest for this international e-conference on recent trends in the nanomaterial and its applications, sponsored by Punyashlok Aili Devi Holkar, Solapur University, Solapur. Now, today I am very happy to introduce our today's resource person, Dr. Gaurav Lohar. I know he from since our MSc days. Dr. Lohar currently working as a head and assistant professor at the Department of Physics, Lal Bahadur Shastri College, Satara. His academic journey is marked with significant achievement, including MSc, PhD from the Shivaji University in the specialization photoelectrochemical solar cell performance. He working on the material science, and most of research is focused on supercapacitor and solar cell materials and fabrication of device. Recently, from December to January 24, he was visiting a research fellow at the Queensland University of the Technology in the Australia under the prestigious DST SRB fellowships. He published more than 60 research articles in national and international journals with citation around 150 and total age index around 22. He submitted a lot of patents and awarded. Also, he leading multiple research projects funded by the agencies like DST SRB and UGC DE, focusing on material science, gas sensor, and vaccine-based device. Also, he awarded number of awards like most prestigious award of Maharashtra Academy of Science Young Associate Award 2025 from the Maharashtra Academy of Science and Young Scientist Award in 2019 from the Indian Science Congress Association. I think his research is focused on development of new device, and currently he guided several research students, and he working on the most important topics like topics ranging from the transition metal oxide and transition metal and DFT theory calculations. Now I would request you to Dr. Gaurav Lohar sir to over these sessions. Hello.
Thank you so much. Can I share my presentation?
Yes, sir. Yes, sir.
It's okay. It's okay.
It's visible? It's visible?
Yes, sir. It's visible.
Okay. So, before going to start my lecture, first I would like to thanks the session chair, Dr. Surendra Shinde, for the nice introduction. And also, I'm very much thankful to Principal of the college, S.M. Mulani sir, Dr. B.B. Navle sir, HOD Physics, Dr. S.S. Dasade sir, IQAC coordinator, and the convener of the conference, J.V. Thomre sir. So before starting my lecture, I want to say something about the convener and the session chair. Dr. Jagannath Thomre and Dr. Surendra Shinde, both are my teachers. So I spent a lot of time with him. And I spent my last year master and whole PhD with them. And I received a lot of knowledge and motivation from these two people. So I want to say thanks to these people. Also, Dr. Dasade sir was also is like my teacher. But when I was started my PhD journey, Dr. Dasade finished his PhD. So very less time I spent with him, but also I'm also thankful to Dr. Dasade sir for his motivation. So my today's talk is basically based on the energy storage devices, but especially I will talk on machine learning. So how can we use the machine learning tool for the energy storage devices is my main aspect of this talk. So in this talk, firstly, I will discuss the energy storage devices. Then I will discuss the nanomaterials, how to deal with the nanomaterials, and then some introductory part of the machine learning. And then we will discuss actually how I use the machine learning for the energy storage devices. And we will discuss some examples like metal molybdates and nickel cobalt phosphate, nickel cobalt phosphides, nickel cobalt sulfides. We will discuss how much we can finish within a time, and at least we will try to finish three, four examples what actually we have done in right now in my laboratory. And this tool is basically use your reduce your experimental time then you can use your more potential in a right way. Then you can reduce your time and uh, uh, you will get a good results in the supercapacitors. So this machine learning analysis is basically based on the previously published data and some models, which models is we will analyze the which model is best for your data, and then we use that model for your analysis of the materials and materials properties and the device analysis. So basically what first question is that what is the energy storage devices, and second what we need, why we need these energy storage devices. If you see the world population is right now is around the 804 crores population on a planet, and around that in that 804 in India we have 150 crores right now. So we have very huge amount of population, and we need energy to a good living thing, good living for the good living, and basically we are depending on the electricity to get the energy and use this as a big energy source. So basically we are collecting energy from the uh, um, different sources, but like solar cells and um, uh, wind source, then hydroelectric generation. Many we have devices to generate the electric energy, and we are using this energy for the daily life. So also, as we think, what actually we need, the how much energy we need. So many different statistics right now published by the different peoples. But if you see the statistics here, so actually we need the 4.2 or nearly about 4 kilowatt energy per day, and typically if the price is about the 10 to 10 rupees per kilowatt, somewhere it is around the 6.5 or 7 rupees per kilowatt, but the estimated cost of per person is about the 10,000 uh, per year. Or if you see the statistics, and if you per person need the 10,000 rupees, then we are near about 150 crore people. So if you multiply the 150 crores, then we get again a big amount of big number, and that much amount of energy we need. Also, we some statistics says that we need the 20 to 30, 26 to 30 kilowatt of energy daily, but also 800 to 1,000 kilowatt kilowatt of electricity per month. So mostly these are the industrial need. So again, we can multiply this with our actual need. Then again, this is a big number. So what actually we need, how much energy? So this is global energy requirement is right now at $3.3 trillion. So and India's GDP is now about the $4.1 trillion. Means how much we need the electrical energy, that is near about India's total whole economy. So we can understand sometimes people are coming to me and asking what is the scope of physics. So this is basically only one sector, that is the energy storage devices, and that sector need more than $10 trillion of investment in the energy storage devices. And now right now world is investing only $3.3 trillion, and the total whole Indian economy is about the $4.1 trillion, about the $4 trillion. Means right now world is invested only $3.3 trillion in energy storage devices, and that is it is a whole Indian economy. So if you saw the world's GDP is about the $117 trillion, and we need the total investment is a $10 trillion. So and at least this is the world's energy requirement is a 10% of the total world's GDP. So this is a very huge amount. So I thought the many people should come here, do some research, and develop some energy storage devices and sell in the market. I thought this is a billions or $1 trillion business in the worldwide. So as we think the energy storage devices, we are firstly thinking on the batteries, and also the supercapacitors and batteries are the materials used in the both devices. As most of the time of these are the similar one. So if you saw the battery market in the world, so right now $181 billion of right now USD 181 billion USD market world is selling the batteries around that of amount, but India is selling only 7.8 to 10.5 billions of dollar only. So if you see this amount, so we are 2 lakh as compared to the other world, and in the world, China, Korea, and Germany, USA are leading in this sector. So, but at in a first slide, I already told we are 150 crore people. So only 7 or 8 or $10 billion big investment is not a good investment in the energy sector, because we have huge in number. So we need a lot of money in this sector. So if you 100 or 600 or 1,000 people created the industry, and they are billionaires, still they are not able to fulfill the total energy requirement of India. So if you see the future plan of the world, so world is projected around 632 billions of dollars up to the 35, and only India is only projected $20 billion up to 3035. So sorry, 2035. So if you see these statistics also, so we are 2 lakh as compared to the world investment in the energy storage devices. So if you think 632 billion dollar up to the 2035, then who is the biggest seller in the world, and who is the biggest buyer in the world? So I know that only India is the biggest purchaser in the India is only purchase more batteries as compared to the other world, because India, we are the one, again we are, I'm saying that we are 150 crore people. So our investment is very less in this sector, and because we are not doing anything in the research and development in the battery and the supercapacitor devices or in the energy storage devices. So it's my request to all the community and those who are listening this lecture. We need to work more and more in this sector. Then we can create. Then we can create a good business. We can sell the nanomaterials. We can develop the device. Also, we can develop the some substitute part of the batteries and the supercapacitor devices. And this is a huge business in the world market as well as the Indian market. So right now in India, so very less companies are developing their batteries, and they are doing some R&D and developing some materials and developing some batteries. So Exide, Amar Raja, Tata Group, Reliance Group, these are the different groups are right now developing their batteries. Also in the world, so Maxwell Technology, Tesla, and Etion, many companies are there who those are the developing the batteries and the supercapacitors. So if you see again, if you see the recent statistics, the BYD company and the Tesla company are right now fighting with each other for the developing some new batteries like sodium batteries and lithium-ion batteries, and they are capturing a lot of market. So if China is projecting near about 47% of world's market of the about the battery. If you see the 47%, it means near about 50%. And if you saw the $632 billion is projected up to the 2035, then near about 315 billion-dollar business only means China only done the $300 billion business in the battery. So where we are right now. So we have to think all this thing. We have to think on these issues, and we have to take efforts to develop the industry and the different nanomaterials. So what actually after discussing the statistic, actually our talk is basically on the energy storage devices and the batteries. So we will focus on these issues. So basically we are generating energy from the nuclear energy, natural gas, coals, and some wind turbines and the solar cell, and then we are converting all these into electrical energy, and we are using this for the daily uses. So when we are thinking to generate the energy, so we have to store the energy is our basic need. So we have the three sources to store the energy. So first is the supercapacitor, second one is a battery, and third one is the fuel cell. So supercapacitor having the long cycle life, higher power density, rapid charge discharge, and low maintenance. Also, it has a high working electrode potential, low equivalent series resistance, high energy density and power density, and high cyclic stability. So this is the basic development of the supercapacitors. Basically, first supercapacitors are developed in the 1950s, and the first supercapacitor was developed started for the only 50 seconds to 70 seconds. Then US companies like General Electricals and other companies, Sohiho, started developing and working on this supercapacitor. And one of the first good supercapacitor is developed, and that was around 1 farad. Again, people started some working on the supercapacitors. New companies also introduced themselves in that industry, like Panasonic in 1980s, and also they are starting developing supercapacitors. So this is a basic history of that supercapacitor. So basically, supercapacitors are divided into three types. Firstly, in the 1950s, supercapacitor basically developed from the electrical double layer supercapacitor based theory, and in that supercapacitor, carbon based materials are used. And in the second stage, in the 1970s, the second type of supercapacitor developed, that is pseudocapacitor, and this pseudocapacitor is basically developed using the metal oxides, hydroxides, sulfides, and conducting polymers. And in 1990s, so third stage, these two electrical double layer capacitor materials and pseudocapacitor materials are combined, and metal oxide, hydroxide, sulfides, conducting polymers are composite with the carbon-based materials, and new type of materials, that is a hybrid capacitor type of materials, are developed. And we are still investing in some materials and trying to improve the capacitance in terms of Faraday per gram, and we are always taking some use of the different nanomaterials and developing some nanomaterials, and still trying to improve energy density and power density of the supercapacitor. These supercapacitors basically not only used in the battery, but these materials are basically used in the different applications also. So like micro supercapacitors, variables, cell power devices, transparent, portable patch, and biodegradables. These are some examples of the supercapacity used in that application. But rather than this, many places the supercapacitors are used. So when we are comparing the capacitors and batteries, the Regon plot is very important. So when we are developing the devices, we are always thinking on the two things, that is the energy density and power density. So what actually mean by the energy density and the power density? So energy density means how much energy device can store, and second thing, how quickly a device can deliver the energy. So if you see the batteries and the supercapacitors, so batteries having a higher energy density as compared to the capacitors and the supercapacitors, and capacitors having higher power density but having a low energy density. So what scientists actually they are started combining the two properties, and they are trying to develop a supercapacitor having good energy density and power density. So supercapacitor also having there are three type of supercapacitors are developed. That is symmetric supercapacitor. So symmetric supercapacitor and having some moderate amount of energy density and power density. Similarly, the asymmetric supercapacitor having shows the good result as compared to the symmetric supercapacitors, and they having the energy density and good energy density and power density. But the hybrid supercapacitors having uh, good energy density as well as power density. So right now, people are mostly trying to develop the hybrid supercapacitor. Then they can combine the properties of the capacitor as well as the batteries, and they can develop the good energy density and power density based supercapacitor. So we need to investigate right now the hybrid supercapacitor. So what is the actually difference between the batteries and the supercapacitors? So batteries, I thought all are well familiar with this because it is very related to safety concern. supercapacitor having fast charge discharge, environmental benefit, long cycle life, and the high power density. So these are some features of the supercapacitor or the conventional capacitor. Mostly, I want to tell you that the capacitors have the conventional capacitors having the capacitance in microfarad and millifarad. But right now, many scientists develop the supercapacitor in the range of thousands of farad, and that is a big achievement. But in terms of energy density and power density, we are right now little bit comparing with batteries in terms of the energy density. But still, we are thinking to improve the supercapacitor on that range. Then we can actually we are comparing with that one is with the battery. So this is basically some introductory part of the supercapacitors. But the how can we improve the supercapacitor is a big question. So right now in the 1990s or 1980s, people have started using different nanomaterials for the development of the supercapacitor. So basically we need to understand what actually the nanomaterials. So basically nanomaterials are divided into four types. There is a zero-dimensional nanomaterial, one-dimensional nanomaterial, two-dimensional nanomaterial, and three-dimensional nanomaterial. So why nanomaterials having more efficient because of their size, and this size is improving their porosity. And if we increase the porosity, we have good solid liquid interface, and then we have good specific capacitance, and we have good efficiency for the supercapacitor. So if you understand the zero-dimensional material, one-dimensional, or two-dimensional, and three-dimensional material, so nanoparticles or quantum dots are the examples of the zero-dimensional nanomaterials, or the nanorods are the example of the one-dimensional nanomaterial. Nanosheets, then nanoplates are the example of the two-dimensional nanomaterial, and spheres, tubes are the example of the three-dimensional nanomaterials. So if your particle size is less and less, then you have good porosity. So basically, zero-dimensional nanomaterials are more efficient than the one-dimensional nanomaterial. One-dimensional is more efficient than the two-dimensional nanomaterial, and two-dimensional nanomaterials are more efficient than the three-dimensional material because of the size and the porosity. So we have analyzed these materials using the machine learning analysis. So if you keep in mind the differentiation of these materials. So if you think about the Cartesian coordinate system, if you material growing in need to the growth of the material is in one dimension, and we need to explain that growth using the one dimension. That means this is only one dimensional material. If we need to explain two-dimensional in a growth mechanism, then it's a two-dimensional nanomaterial. And if you need a three-dimension to explain the material, then it's a three-dimensional nanomaterial. So what are the different types of the nanomaterials used for the supercapacitor? So first is the carbon-based materials, and the carbon-based materials are consistent with the EDLC type of the supercapacitors. So graphene, carbon nanotubes, activated carbon nanofibers are the examples of the EDLC type of, or the carbon EDLC type of the material, and those are the also type of the carbon-based materials. So carbon-based materials having high surface area, excellent conductivity, and long soil cycle life. Second type is the metal oxide nanomaterials, and this is the one of the great example of the pseudocapacitive materials like metal oxides, like ruthenium oxide, manganese oxide, cobalt oxide, iron oxide, etc. So these materials also high specific capacitance, but the capacitance is basically based on the redox active behavior. So third one is the conducting polymers, and it contains the polyaniline, polypyrrole, or PE dot, this type of polymers, and we are specially analyzing them for the use of the supercapacitors. So these are also having high capacitance. We can develop the flexible electrodes using the conducting polymers, and also having the fast charge discharge time. But they having limitations like they are not more stable. So fourth one is the transition metal chalcogenides. So metal chalcogenides contain the sulfur, selenium, and telluride group, and the mostly molybdenum surface sulfide, tungsten sulfide, nickel sulfide, cobalt sulfide. These are the different examples of the transition metals and chloride-based materials. So in the hybrid material, for the making the hybrid, we are using the advantage of EDLC type of materials and the pseudo-capacitive type of materials. And we are combining the both properties. So metal oxide and carbon-based material we are compositing, or polymer and metal oxide-based materials we are making some composites of that material and use the further making the hybrid and composite supercapacitor. So metal oxide with the graphene composite and metal oxides with the polymer, these are some example of the hybrid materials. So basically, what is the machine learning? Now we understand the supercapacitor. Then secondly, we understand what are the nanomaterials, and third one is what is the machine learning. So this is a very advanced tool. In the last month, I delivered lecture in the Solapur University, and after my lecture, many young people come to me and they shown many things about the machine learning. Actually, they're done. So I thought young people are here, and probably they know more than me about the machine learning, and probably they perform many tasks using some Python and machine learning to analyze the different things, and probably they develop many softwares. But here I'm just talking about the introductory part of the machine learning. So what actually the machine learning? Machine learning is the programming, or it is a one part of the artificial intelligence, and it contains some data, and we are analyzing some data using rather than thinking the human, we are giving some chance to the machine to think on that data and give some output. So basically, we are giving some data as an input. We are doing some programming, and we are getting some output, whatever desired we need to understand about the supercapacitor devices. So actually, machine learning is more like gardening, like give some seeds, like use some algorithms, use some nutrients, like give some data, and gardening. So give some water and take care of that. So it means you and plant is growing in some, you are growing some programming, and that programming you use for your multiple users. So in the machine learning, so there are basically three types of machine learning. That is supervised machine learning, unsupervised machine learning, and reinforcement machine learning. So basically in this, for the supercapacitor devices, we are using the supervised machine learning to analyze the supercapacitor devices. So these are the different classifications and whatever need for to understand the machine learning. That is mostly these are these used for the disease detection, mail spam detection, or house price prediction, stock price predictions. So supervised machine learning is used for also different applications. So in my work, I used different models to analyze the supercapacitor devices. That is a linear regression model, logistic regression, support vector regression, k-nearest neighbors, X-booster, random forest, and decision tree. So this machine learning is like a mathematical modeling, but it is not actually the mathematical modeling. So like we are making some program on the differential equation, integration, or some matrices. We are developing some density matrix. But like that, when we are for some complex data, when we are not able to fit the data with these mathematical tools, so we are using some machine learning model to analyze the data. So different mathematics is developed with these models, and these models are the programs in written for these models in Python and MATLAB and many other languages. So basically, I use the Python language to develop these models and analyze the data. So first, I collected the data, then we clean the data in desired format. Then we select the model, we run all model for the data. We identified the regression factor, which is near to the one for the model, and that model we use for the next use. And then we train the model, and we evaluate the model for the data analysis. So right now, I discussed the machine learning, introductory part of machine learning, and now I will use this machine learning model for the nickel molybdate and graphene based composites. So what are the advantage of the nickel based materials? The Ni is the most abundant element, having a low cost as compared to the ruthenium oxide. And ruthenium oxide is one of the best materials in the supercapacitor, but the price is too high. Also, the molybdenum-based materials are the environmentally friendly. Nickel is offering Ni2 plus and 3 plus oxidation state and having high theoretical capacity. So like graphene is also high electronic conductivity, last specific area, high porosity, high electrochemical activity, good mechanical properties, and good electrochemical and thermal stability. So we are combining these combine these materials. We have collected the data and we analyze the data in the zero-dimensional material, one-dimensional material, and two-dimensional materials. So all these materials we are characterized in identified using the Cartesian. We are by considering using the Cartesian coordinate system. And this is one of the graphical abstract we have published this image in the battery energy journal. So if you see about the molybdenate based materials, so we have iron molybdenate, nickel molybdenate, cobalt molybdenate, zinc molybdenate, and manganese molybdenate. So these materials developed the different morphologies they developed using the chemical methods or the physical methods, but only one-dimensional, two-dimensional, and three-dimensional materials are only developed for the developed for the molybdenate based material, but still now no one is developed the quantum dot based materials for the molybdenate. So we have basically collected data from the literature. From the last 20 years, we have collected paper, whatever published in the world science community, and we have analyzed, we have collected the data for the cobalt molybdenate, manganese molybdenate, zinc molybdenate, iron molybdenate, and nickel molybdenate. And we created some tables. What are the specific capacitors? Which method we people are using? What actually the morphology? How much is the specific capacitance? How is the cyclic stability? Different parameters we identified. We collected data and we started analysis of that all the reaction mechanism and the experimental parameters and many things. So if you see the things, what are the one-dimensional nanomaterials and which methods are able to develop these metal molybdenate based nanomaterial, machine learning given good results. Machine learning shows that the nanowires, nanorods, nanotubes, and nanofibers are developed by the researcher using the hydrothermal method, microwave method, chemical co-precipitation method, solid state method, etc. But if you see the data, the only hydrothermal method is leading in this molybdenate. And we received a very high specific capacitance, approximately near about 1800 Faraday per gram for the nanowires. So nanowires are able to perform more as compared to the other one-dimensional nanomaterials like nanorods, nanotubes, and nanofibers. But if you see the chemical methods, only hydrothermal method is leading as compared to the other methods and having more specific capacity. So if you see this graph, you are able to develop the new topics in the you can develop the new thesis and research topics by using this data, because if you want to develop the devices, go to the hydrothermal method and try to develop the nanowires, then your device will be run they will run with a good efficiency. But if you want to explore the different chemical methods with the different morphologies, then you go to the nanofibers and nanotubes. So if you see the data, only electrospinning is able to develop the nanofibers and nanotubes. So you have a lot of novelty here. You develop the fibers and nanotubes using the different methods. This is the novelty of the material. I thought this paper will be published in the more than 10 impact in the world science. So also, if you see the solid state chemical method, only one paper or two papers are published in in the science community about this development of the one-dimensional nanomaterials. So many other methods are also we can observe here. We are not able to see they are developing some different one-dimensional nanomaterials for the molybdenate material. So you have a chance to develop and grow the different one-dimensional nanomaterial with the different methods other than the mention the mention the methods. This is the novelty of your material. Similarly, we have analyzed the two-dimensional nanomaterials, and we identified the only nanoflakes, nanosheets, and nanoplates are developed for the molybdenate-based materials. And other than this, we are not able to develop anything. Again, here we observe that hydrothermal method is leading only. Hydrothermal method shows that specific capacitance around the 2,500 Faraday per gram. But other than this, no other method is leading, and only 6 methods are here. Those are able to develop the two-dimensional nanomaterials, and only hydrothermal method is leading here. So other than this, you can use any method to develop the molybdenate-based materials, and you can develop the different morphologies with that. Then these are the new topics and new PhD topics for any students. In a similar manner, we analyzed the three-dimensional nanomaterials. And if you see the three-dimensional nanomaterials, nanoflowers, nanocubes, hexahedrons, nanospheres are developed by the researcher, and only hydrothermal is leading. And along with the simple chemical methods is leading, only having 1 point, and other than this, no data is available in the science community. Those are explaining about the development of three-dimensional nanomaterials using the chemical method. So a lot of scope here to work on these materials. The only hydrothermal method showing the specific capacity around 1,400 Faraday per gram. So if you see actually the results, one-dimensional nanomaterials having the maximum specific capacitance about the 1,800 Faraday per gram. Two-dimensional nanomaterials having the specific capacitance about the 2,500 Faraday per gram. And the three-dimensional nanomaterials having the specific capacitance about 1,400 Faraday per gram. Then in this case, the two-dimensional nanomaterials having more efficiency than the one-dimensional nanomaterials. It means that if you first we discuss about the nanomaterials, and I said that the theory said that the zero-dimensional nanomaterials having more porosity than having more, they are more efficient than the one-dimensional nanomaterial. One-dimensional material is more efficient than the two-dimensional nanomaterial, and two-dimensional nanomaterials having more efficient than the one-dimensional nanomaterial. But here we observe that machine learning analyzed that two-dimensional nanomaterials are more efficient than any other material. So basically, this is some little bit of contradictory result, but these are the actually observed results. But it means that we are not able to develop the one-dimensional nanomaterial very easily. We are not able to control the environment very easily. Then very less research papers is published in the science community to develop the one-dimensional nanomaterials, and no any single paper is published on the quantum-based materials for the molybdenate. And this is I thought the good achievement of the machine learning result. They are showing everything in a one graph. So along with this, we have analyzed different parameters, and we have compared the different morphologies, how they are behaving, how the supercapacitor behaving with the different nanomaterials. If you see the first graph and the second graph in this area, so all morphologies we have combined, and UPC methods we have combined with respect to specific capacitance. If you see the microwave method is more consistently giving some results. Also, hydrothermal method is leading in this, but not consistent result here. So hydrothermal microwave method is also having good data points, and if you see the solid state chemical method having good data points, and other than these methods, very less data is published and very less research is performed for the metal molybdenate based material. So similarly, if you see the morphology, then only nanorods having the more efficiency, and the nanowires having the more efficiency than the other morphology. But if you see the 6 and 7 morphologies are leading, other than this, no one is developed different morphologies than this. So we have again good scope to work on these materials. So if you see the which parameters are more influencing to develop the metal molybdenate based materials, so synthesis, which synthesis method is there? Metal precursor and their molarity, molybdenate precursor and their molarity. What is the actual reaction time? What are the reaction temperature? What are the actually annealing time and annealing temperature? These are the leading parameters. If you see the N graph, if you understand that these are the more leading experimental parameters. So, or you can say these are the more influenced input parameters for the on the specific capacity. If you see this the M graph, you can understand we run the different models to uh, analyze the data and lasso regression is showing the good R factors. Then we use this lasso regression for the analysis of the different data, like what should be the metal precursor, what should be the molybdenate precursor, what should be the solution amount, what should be the reaction time, what should be the reaction temperature, etc. So also we have generalized the equation. That is, I thought this is my big contribution in the theory. Basically, this is a very small equation, that is the predicted specific capacitance is equal to 0.85 into the actual supercapacitors plus 197.84. So when you are doing some experiment and calculating the specific capacitance for the molybdenate, you use this equation to compare your actual results, and you will identify this. You will plot somewhere here in this O graph. So we have actually machine learning given these predictions. So this is, I thought, a little equation, but big contribution for the material. So my belief is that if you're working on the molybdenate based materials, and then if you do some experiment and you calculated the specific capacitance, you will not cross this equation. You will you will satisfy this equation. So this is the best, good output of the machine learning. So these are the most influence parameters and the trend data. So our correlation is near about the 0.96, means is near about 1. So we have again a chance to develop the new nanometer, add some data and improve the machine learning result up to the 9.99999. So we have again a chance to improve 0.04%. You can say we have a chance to improve 4% of this data. So we have used this machine learning again analysis of the devices, supercapacitor devices who fabricated with the metal molybdenate, fabricated with the metal molybdenate. So specific capacitance, energy density. If you saw the specific capacitance, so very less, moderately paper showing that this material showing specific capacitors around the 126 Faraday, and the energy density is about the 38 watt per kg. And if you saw the specific capacitance versus energy density, having showing some correlation, but the R factor is a little bit less. So I am not created any equation for that. So we have more chance to develop this type of materials. So again, if you see the energy density versus power density graph, so all data is placed in between. These molybdenate materials are the battery type of materials, having also having some hybrid capacitor type of results, but these results are very less. But these materials showing good energy density and power density. But most of the point you can observe this is in the battery energy range. This my paper is published in the Village Journal Battery Energy, having impact factor 9.9. So like this, we have solved many examples. I thought more than 15 minutes are over, but I will take 10 minutes more. Surendra sir? Hello?
Yes, sure.
Yeah, can I take 10 minutes?
Sure.
Okay. So I will just quickly discuss what are again, we have analyzed some phosphate-based materials, such as nickel cobalt phosphate and nickel cobalt phosphate, how we use the machine learning and we identify the results. So I will discuss only main results. So in this also many methods, by using the different methods, phosphate based materials are developed, but again here the hydrothermal method is leading. Also if you see the morphologies, so sorry, if you see the different methods with the comparing their specific capacitance, hydrothermal method having good results and consistent result, but the co-precipitation having showing that more specific capacitance. So but other than these methods, again we have very less number of data. So in the metal molybdate zero-dimensional materials are not developed, but in this case, only two-dimensional and three-dimensional materials have developed. So anyone is thinking about the development of the phosphate-based materials, nickel cobalt phosphate-based materials, then you start working on how can we develop the one-dimensional nanomaterials. Then this is a novelty, and probably they will publish again in the more than 10 impact factor, because no any paper is published on this. So specific, and if you see the morphologies, so nanosheets having the more results. So nanosheets is an example of the two-dimensional nanomaterials, and it's having the specific capacity about 3,500 Faraday per gram. So here we are again used some cluster analysis. This is another different part of the machine learning. So by using the cluster analysis, we some discrete data for the discrete data. We have created some clusters, and we have taken some average, and by taking some average, we have created some trends, and we have identified the which parameters are more influencing. So nickel precursor, cobalt precursor, these are some mentioned parameters are more influence parameters to develop the nickel phosphate based materials. So these are some internal parts, means some experimental parameters we have analyzed using the machine learning. So you try to follow this paper. This paper also is published in Journal of Material Chemistry. So by using the heat map, so you can analyze the which parameter only this graph can explain. Machine learning graph can explain everything. So which parameter we have compared every this parameter with the same parameter. So one means these parameters compared with these parameters, same parameters. So showing the one. But if you see these data points, you can identify any one parameter how can change their data with respect to other parameters. You can compare the all parameters. So actually, this is the means good output of the machine learning. So same phosphates, and this is the phosphites. So same things we have done with the phosphites. So this paper is published in Journal of Material Chemistry. And for the phosphates and phosphites, so for the phosphate, these are the more influencing parameters. So these are the 5 parameters are more influencing, like reaction temperature, which nickel precursor is there, what are the phosphites precursor, what is the actual pore size and current density. So mostly what people are actually doing when they are starting doing some experiment, they are following some traditional path, and they are changing some reaction temperature, they are changing some reaction time. So that's why very less data is published on the other precursors like metal precursors, and what is the varying the surface area, then reaction annealing temperature, cobalt precursor. So very less time this variation of these parameters is very less time studied. That's why those are the not more influenced parameters. So we have again a chance to think on these parameters, create some new experiments on these parameters, and develop some experiment. Then those can be influenced on the specific capacity. So like this, we have developed different materials. So we have also analyzed the nickel cobalt sulfide based materials. Also, we have good results. We have a good understanding about that, and here also similar type of results. What type of different morphologies they develop with respect to the specific capacitance. Also, we have discussed every parameters, annealing time, annealing temperature with respect to the specific capacitance, and also we have developed the predicted specific capacitance situation for the nickel cobalt sulfides. So these are the results for the composites and device. We have again identified the machine learning results with the composite with graphene, and which different morphologies they have created is mentioned here. Also, we have calculated the trend equation for the machine learning trend equation for nickel cobalt sulfide and graphene composite using the machine learning. And this paper is also published in Chem journal in the village. So this is one of the good results about the battery. We have used machine learning analysis for the lithium iron phosphate LiPpo for battery, and also we have created some equation for that by using the machine learning. So we have good chance to explore the different materials using the machine learning. So these are some morphologies whatever observed for the lithium iron phosphate, and this showing that what actually the capacity for that morphology and for that method. So this paper is not published yet, and right now we are working on the Maxim-based composites for the using the machine learning. And recently I have finished this work in the QUT and Queensland University of Technology, and we have collected a lot of data, and this is the project data of my SIRI fellowship. And so hope so recently we will publish that data. And these are some primarily machine learning analysis of the Maxim-based devices. So also my further Maxim-based devices, electrodes, composites, potential, power density, energy density, cyclicity ability. These are the more influenced parameters for the Maxim-based composites. So actually, these are my papers published in the good journals in the battery energy, Journal of Material Chemistry, Chem, and again in battery energy. Those are published papers in the on machine learning based analysis for the supercapacitor devices. So this is a this I'm happy that this type of papers very less people are published in the India on the used for the analysis of the battery and supercapacitor based materials. And my group is one of them who generated some trends in the machine learning and analyzed the different materials. So these are some devices I have developed in my laboratory. We have that is the output of my research project, and I'm happy to tell you that one of my students from the Dr. Onkar Pore is from alumni of the your college, and he developed this small devices in the laboratory while working on my young scientist project, that is an early career research award project. And this right now we have developed the these supercapacitors devices in the laboratory by using the metal molybdenate, and we are right now able to glow the 28 LED with the 4 devices, and these devices can run for the 1 hour. So that is a good achievement of the fabricating device as well as the guiding of machine learning. So these are two, after publishing these research papers in the good journals, these journals invited for the cover page because of this is the new trend of machine learning. So battery energy in the electron journal, we have published the cover page images also. So these are the book chapters I have published. I have written in the so many book chapters I have written for the international books. These are the books where I have published the book chapters, and also have edited one book here. This is my research group, and right now working in the laboratory. Recently, just 1 month ago, Dr. Digambar Sawan finished his PhD, and right now this is my team is working for me. Actually, this is not my credit. Actually, my team is working behind me. That's why I'm able to explain here something. So these are my research students working in the laboratory and doing some constant efforts in the laboratory to do some machine learning, do some computation, develop some devices, and develop some nanomaterials. So this is my research laboratory. I have a lot of instrumentation, good instrumentation I have collected from the different funding agencies, some common projected, some individual individual projects, and we are using these resources for whatever resources we have for doing some small research. So these are instrumentation available with me, whatever necessary chemical methods I have in my laboratory for developing the materials and developing the devices. Thank you. Thank you so much.
Thank you. Thank you, Lower sir. I would like to thank you, or sincerely thank you, for such a beautiful and clear lecture on the critical role in energy storage in this today's world. Also, your expertise is highly major how to solve this issue and how to cover challenges in the field of energy storage system and why supercapacitors are serving an important solution in modern energy society. So now this session is open for the discussion. Hello. Hello everyone. Now this session is open for the discussion. Gaurav sir, I have one question.
Yes, please, sir.
Why poor size is important than the other parameters for the improving performance?
As if you see the theory of the development of the nanomaterials, so if you have more porosity, it means you have more solid liquid interface, and then you have, if you have more solid liquid interface, then you have more efficiency. So basically, zero-dimensional materials having more porosity than the one-dimensional materials. One-dimensional materials having more porosity than the two-dimensional materials, and two-dimensional materials having the more porosity than the three-dimensional materials. So basically, for the batteries and supercapacitor or any application where solid liquid interface is done, porosity is play a crucial role. So developing the porous materials for the developing some efficient supercapacitors or the batteries is a main and important task. So for the porosity is a very crucial parameter.
Okay, thank you. Anyone?
हेलो सर.
Yes, sir.
Sir, आपने we have shown one more equation, practical capacitance,
Specific
0.85
predicted
plus
specific
actual
capacitance.
capacitance.
Yes.
0.85 actual capacitance plus 197.84 equation. That
Yes,
is this. But how to calculate this equation means?
This is a line
background
equation actually. See this graph. See this
Okay.
graph.
This is the
This is
regression.
yeah. This is the actual specific capacitance versus predicted specific capacitance, and this is developed by the machine learning model. So machine learning model is developing this and predicting something about observing some data. So by observing data, if you see that this is the test data, black points are the test data and red points are the trend data. So this trend data
Trend.
is given by the machine learning, and this is the output of the machine learning. So this is when you fitted this line, I have written the equation for that line, that is y is equal to mx plus c. And if you see this equation, then y is the predicted specific capacitance. AS is an actual specific capacitance, and these are some constant factors like M and C.
Okay. So trend capacitance calculated by using DFT theory. Which
This is another different part. You have to do some actually all these analysis I have done in the Python, but my expertise is more in DFT as compared to the machine learning. So what actually, when you are if you try to combine the two things together like DFT and machine learning, so you have to create some data using the using the DFT. And if you create some theory calculations and created or calculated some quantum capacitance for the multiple morphologies by using some multiple methods or using some different parameters, then you can analyze also that data using the machine learning tool, and you can create the same equations. So right now we are planning we are working on that, but still we are not able to publish a good paper by combining some DFT and machine learning. Hope so in a short time we are able to publish a good paper on the same issue.
And one more thing, sir, we have used means generally phosphate-based material, but phosphate-based material is a highly redoxive behavior. It's like as a battery material. So we have generally used as a supercapacitor. Then this material shows a redox behavior. But in capacitor, the charge storage is occurs only on the surface. But in this material, means phosphate-based material, occurs combined behavior, like as a diffusion controlled and surface controlled behavior. So how to clarify the battery type or supercapacitor, means hybrid type material?
See, if you see the charge discharge curve, then we are analyzing basically on the charge discharge curve. Then if you have triangular shape, then you see this is a pseudo-capacitive type of material. When we are charging the material, then we have some loss, and then again some long point, and then at the end of initial discharge. This is a basically battery type of behavior, right? And the phosphate based materials are showing the battery type of
But
behavior.
but by using this SCD, means charging discharging analysis, the charging and discharging timing is near to or less than to discharge time as compared to charging time. That the efficiency is less than 100%. But
No,
as
so
compared to
that is
battery,
at that
as compared to battery, the discharging time is larger than the charge.
this is the motto of actually. I'm audible.
Yes, yes, yes.
Actually, this is the actually motto of supercapacitors. So your charging time should be less as compared to the discharging time. But the thing is that when you are thinking about actually charging time and discharging time, then you can explain this using the Coulombic efficiency. So you talk about the basically Coulombic efficiency, then you can compare how material is means how much is the right now the Coulombic efficiency for the phosphate based materials. Then you can able to compare the how much is the charging time and how much is the discharging time. And this is we can explain in only one word, that is a Coulombic efficiency. So your Coulombic efficiency is good, then your material is again good. If your Coulombic efficiency is less, then again you have to do some good experiment and you have to make a purity for the phosphate based materials and develop the good devices.
Good morning, sir. This is Shivani Gavande from Solapur University.
Yes, ma'am.
Sir, I wanted to know what are the necessary skills or expertise that a research scholar should imbibe for approaching the DFT analysis? Because, like personally, me, I'm not used to any simulations or programming like Python or etc. So, at the preliminary stage, what a research scholar should know in order to
basically research scholars to know basically two things for that. Actually, this is not a topics today, but I will explain you. Basically, two things: we need good understanding of the solid state physics, and second and important thing is a good knowledge of the quantum mechanics. How can we use the Schrödinger's wave equation for the? How can we use the actually one Schrödinger's wave equation? And you can solve also these Schrödinger equations for the one means hydrogen atom, and then you can study the different approximations how for the used for the Schrödinger's wave equation. Then you should know what is actually the material science and solid state physics, actually crystallography and crystallography based parameters, and then you have to combine the two things together, and then you can go for the DFT. But you need good server for the DFT, because from the last week also I am facing one problem about the phosphate, whatever the machine learning I told about the phosphate based sulfate based materials, and I'm right now I'm running one program, and it took more than 7 days for the one simple program. So you need to understand about you have to read about the quantum mechanics, you read about the solid state physics, and you need one good server.
Thank you, sir.
Thank you, sir. Now I am going to the conclusion of these sessions. These sessions and discussion of this session is very useful. I think this session is practically and valuable knowledge for the every researchers. So finally, I'm going to the final remark of these sessions. So thank you, Lower sir, for your valuable lectures on the machine learning process. And I think this lecture is useful for everyone to create and calculate new parameters using this machine learning process. So finally, I would like to express my sincere thanks to Department of Physics and IQSC at the Dr. Ganpatrao Deshmukh Mahavidyalaya for inviting me as a chairperson of these sessions. Also, I will thankful to organizing committee for their hard work to organize this event. And finally, I'm this session over concluded, and this session I hand over to the convener of this conference.
Okay, thank you, sir.
So much, Surendra sir.
Yes, sir.
Thank you so much. Now it is time to conclude the session with vote of thanks. Now, on behalf of my college and organizing committee, I would like to express my sincere thanks to chairperson of this session, Dr. Surendra, for his graceful and presiding over this session, for his valuable presence and thoughtful observation, and also he has given a specific direction to the proceedings. I am truly grateful to him. I extend my gratefulness to our resource person, Dr. Gaurav Lohar, for delivering such an insightful and enriching presentation. Gaurav, your expertise, your clarity, your thought, and your depth of knowledge regarding the supercapacitor, hybrid capacitor, symmetric and asymmetric capacitors, and also power density and energy density of the supercapacitor. You have also elaborated your expertise in the field of nanomaterials, which will be greatly benefited to all participants. The ideas and the perspective you have shared will certainly inspire to all the participants. One of the remarkable thing about Dr. Gaurav is that he has published one of his review article in Springer Nature Journal having impact factor more than 39. So I am grateful to him, and he is one of my best friend and one of best researcher from this nearby two, three universities. He is one of the young scientists, and he is having one of the eminent personality. I also thank to all participants for their active involvement and meaningful interaction, which will make this session very interesting and successful. Once again, I convey our great sincereness and appreciation to the chairperson and resource person for making this session memorable and remarkable. Thank you, one and all. I invite Dr. Thomre for continuation of the further session.
Thank you, sir. I would like to begin with session 5th. The resource person is Dr. S.L. Kadam. She is a Brainpool Fellow at Seoul National University of Science and Technology, South Korea. And the chairperson is Dr. R.A. Bugad, sir. He is Associate Professor at Department of Physics, Sangola Mahavidyalaya, Sangola. And now I hand over the session to us, Dr. R.A. Bugad, sir. Bugad, sir, it's over to you. Hello, Bugad, sir. Please.
You are not audible.
You are not audible.
Thank you, sir. Very good morning, sir.
Good morning.
I am audible, sir.
Yes, sir. Yes, sir.
Very good morning to everyone. Very good morning to everyone. Very good morning to everyone. Welcome to 5th session of International Conference, e-conference on recent trends in nanomaterials and its application, 2026. As the chairperson of this session, I warmly welcome all participants from different regions. First of all, I would like to express my sincere gratitude to the convener and organizing committee of this conference for giving me the opportunity of chair this session. It is my great pleasure to introduce today's distinguished speaker, Dr. Snehal Kadam, a senior researcher in the field of energy storage material. She is currently working as a Brainpool Fellow at the Research Institute of Green Automobile Technology, Seoul National University of Science and Technology, South Korea. Dr. Snehal Kadam has extensive research expertise in advanced energy storage materials, high entropy ceramics, nanostructured electrodes, and supercapacitor technology. With strong international research expertise, she has made significant contribution to the development of innovative material using techniques such as a hydrothermal synthesis and spray pyrolysis. Um, Dr. Kadam earned her PhD in physics from the Institute of Science, University of Mumbai, India, and has served as postdoctoral researcher at Seoul National University. She has published more than 35 research papers, holds 2 patents in Korea. She has received several prestigious fellowship and award, including the Brain Fellowship from South Korea. Her H index is 14 and her total citation exceeds 591 on Google Scholar. Dr. Kadam has presented her research work at numerous international conferences and continues to make impactful contribution to the field of energy storage and advanced materials. We are honored to have Dr. Snehal Kadam with us today to share her valuable insight and research finding. Thank you very much. Welcome to Dr. Snehal Kadam. Thank you very much.
Thank you, sir. Thank
Thank
you very much, Bhugur sir.
Welcome, madam.
It's my great pleasure to take my introduction from Bhugur sir. I had previous experience to work with Bhugur sir, and I have learned many things from the Bhugur sir. And I'm really thankful for the organizing committee of this conference. And all are my gurus, and I'm little bit nervous where I have learned the many things where I started my initial research, and today now I'm presenting my research work in front of them. So it is very great. I am feeling very grateful for that, for giving me opportunity to learn and grow more and more. So I can I share my screen, sir?
Yes, sir. Yes, madam.
Yes, madam.
I think uh, my screen is visible, sir.
Yes, madam. Yes.
My talk of today's presentation is from lab to life, progress in supercapacitor electrode materials for real life electrochemical energy storage applications. So this is the outline of my presentation. Today, I will first briefly.
Madam.
Hello. Yeah.
Your PPTs are not visible. Only.
Open your
Just a minute, sir.
Okay.
Your desktop is visible. You do share the PPT. First share your desktop, and after that you do click over to your PPT. Yes. Now click to PowerPoint presentation.
Now is it visible, sir?
Yes, it's visible.
Thank you, sir. Sorry for delay. My topic of today's presentation is from lab to life for supercapacitor for real life
From
electrochemical
lab
energy.
life progress in supercapacitor.
So this is the outline of presentation. Today I am presenting. Firstly, I will briefly introduce about the Brainpool Fellowship Program and what are the research opportunities and fellowships in South Korea. Next, what are the electrochemical energy storage systems? How we can, what are the classification of electrode materials and what we are working here and with various design strategies for application to the supercapacitor, some experimental results and real life applications of supercapacitor. So the main motto to introduce the Brainpool Fellowship Program here, because yesterday the Brainpool 2026 call has opened. Can you see the Brainpool Fellowship PPT right now? Hello, sir. Does that?
Yes, yes, it is
Yeah.
it's visible.
Yeah. Yes. So Brainpool Fellowship mainly for the postdoctoral candidates who have completed their PhD, and here mainly it is for overseas excellent scientists recruitment program funded by Ministry of Science and ICT Korea. Its program vision is mainly strategic recruitment of outstanding overseas scientists, support innovative and high impact research outcomes, strengthen national and research competitiveness, and build various cycles like discovery, recruitment, settlement, and utilization. So, in In Brainpool Fellowship Program, it invites top overseas scientists to Korean institutions for promoting internationalization of research environment. It secures the new growth engines, foster young researchers, and expand global research network. So what are there are two types of Brainpool Fellowship Program. First, BP, individual, and BP plus. These are the mainly two types of BP program. In BP individual, approximately more 80 plus projects are there, and it's mainly for 1 to 3 years you can apply for it, and after 3 years also you can get one more time extension, and fellowship amount is 350 million KRO per year. And for that it is joint research program, so we need one Korean PI and overseas scientists. And second is BP plus, which is institutional type fellowships, and in which there are approximately 5 projects, and it is for 5 years, and it is very highly prestigious fellowship in South Korea, and it has 2 stages. You can take 2+3 stage, or you can extend also, and its fellowship amount is up to 3 billion Korean won per year, and institute recruits more than top 2 level scientists annually. So what are the eligibility criteria for this Brainpool Fellowship? So mainly for overseas scientists, the overseas scientists should have must reside outside of Korea. They should have they should hold the PhD degree, and they should have 5 years of overseas industrial R&D research experience. And for BP individual type, BP fellow should continue his or her research in Korea, and for BP plus, greater than 40% annual residence in Korea is required. And for these two type of fellowship in Brainpool, we required the principal investigator. And for principal investigator, eligibility criteria is for BP individual, the PI should assistant professor or senior researcher or above, or for BP plus, in your PI should head of the institute as a PI or dedicated extensive executive research manager required. So, and what are the funding? So BP is one of the most prestigious fellowship in South Korea, and it has salary varies from 5 to 25 million KRO per month based on his or her annual salary. And it also gives the research living allowance about up to 1 million KRO per month, child education support for up to 5 million Korean won for first year. Also, they are supporting moving and airfare expenses. And second, they are also providing the research activity expenses, which are about 5 million Korean won per year. And also, they are giving the research material cost up to funding for research material cost up to 1 million %, must salary support for settlement and research cost. And also they are supporting the infrastructure and equipment facility. And so these are the main advantages of BP and BP plus fellowship. So yesterday this call has opened, and its deadline is up to, we need to submit our proposal up to the 14th April. But before that, we need to anyone who want to apply for this BP fellowship, they need to search the PI, then make the proposal. So the proposal system is mainly we can submit the proposal in English as well as Korean language, but mostly the Korean PI prefers to submit the proposal in Korean language. So anyone want to apply for this fellowship should get the host quickly and make your proposal ready, so you can follow this procedure. And its joining procedure is from the 1st July. And after that, they have one annual GRNS conference, which is Global Research Network in Seoul. So there, many international BP fellows also and candidates are meet together and share their knowledge. And its application system based on the IRS, which is Integrated R&D Management Systems. So here is the website. You can search about these fellowships. Next is the Global Research fellowship for the students who want to do post-graduation and PhD. So here you can search about this fellowship more by using this website. So this is the introduction. In previous talk, Dr. Gaurav Lohar sir has given such a nice background about the energy storage technologies. So I am giving little bit brief about what are the energy storage systems. So mainly energy storage system is divided into the 4 types, which is mechanical energy storage, thermal energy storage, electrical energy storage, and electrochemical energy storage. And these energy storages are used for various applications, like mechanical energy storage devices are used in power grids, frequency regulations. Thermal energy storage are used in concentrating solar power, industrial processes, and thermal management. Electrical energy storage devices are mainly used in transportation, renewable energy integration, backup power supply systems. And electrochemical energy storage, mainly supercapacitor, battery, fuel cell, they are used in the portable electronics, transportation, healthcare, and recently they are using in the aerospace sector. So our main focus is the electrochemical energy storage devices, which consist of mainly battery, supercapacitor, and fuel cell. And these electrochemical energy storages performance can be compared by using the Ragon plot based on its power density and energy density. And if we see this Ragon plot, we can see that supercapacitor is fall in between these traditional capacitors and batteries, and supercapacitor has high energy density, high power density, and limited energy density. So what is the global market of this supercapacitor? Currently, if we see this trend from 2023, the global supercapacitor market is projected to increase from 4.3 USD dollars to the, in future it will go about 21.7%. And mainly supercapacitor markets, EDLC based materials are mostly attracting for the electric vehicle sectors, and after that pseudocapacitor based materials and hybrid supercapacitors. And it is these supercapacitors are used in various sectors like automotive, consumer electronics, energy, industrial, and healthcare, and others. So recently, automotive sector has grown very much for various transportation application. And here, by this Kaggle report, we can see how much supercapacitor is increased from the previous decades to the now. From these graphs, we can understand that how supercapacitor is important for supercapacitor as energy storage device, important for our society to fulfill our energy demand. So mainly, as Dr. Gaurav Lohar sir explained previously, supercapacitors are divided into the mainly three types based on its charge storage mechanism. One is EDLC, pseudocapacitor, and hybrid capacitors. And in ADLC, charge is stored by surface reactions. In pseudocapacitor, charge is stored by redox reactions. And in hybrid, which combines charge storage mechanism of both EDLC and pseudocapacitor. So how we can identify the which material is pseudocapacitive or EDLC based material or hybrid based, by using our charge cyclic voltammetric graph, galvanostatic charge discharge graph. So here we can see that for EDLC, the CV graph shows complete rectangular nature due to the charge storage and only at the surface side. And here we can see for EDLC, we can see the galvanostatic charge discharge shows the triangular like nature. For pseudocapacitor, this EDLC CV graph is showed the CV graph shows the quasi-pseudocapacitive type nature, quasi-rectangular type nature, and while the charge discharge graph also shows nearly triangular nature but little bit hump due to the oxidation and reduction reaction in between electrode and electrolyte interface. And for identifying the battery type electrode material, like previously one of the they have asked how to know the material is battery type or pseudocapacitor type. Here we can see from the CV studies, like here for battery type material, we can directly see pair of redox peaks, and also the charge discharge type also shows the presence of hump due to the redox reaction. So by using our electrochemical analysis techniques, we can also identify the type of electrode material. So next, what are the matrices affecting on the various parameters of supercapacitor, like specific capacitance, energy density, and power density? So specific capacitance of the electrode material is mainly affecting by using based on the experimental thickness, experimental electrode thickness, experimental setup, and mass loading. So these three factors also affecting on our performance of supercapacitor electrode. Also energy density also is affecting on the based on the our electrode material. Next is the next parameter is the operating voltage, which also which also affected by the electrolyte or type of thickness of also electrode material. And next is the resistance, internal series resistance, which on which current collector, dwelling time, additives, these are also affecting the internal resistance of the electrode material. So these are the various matrices, so which are affecting the various parameters of supercapacitor electrodes, like specific capacitance of operating voltage. So while we are designing the materials, we need to think all these parameters to get the optimized electrochemical performance. So next, this is the various types of electrode material for used for these supercapacitor application, mainly carbon-based materials, which includes activated carbons, carbon nanotubes, graphene, reduced graphene oxide, carbon aerogels, and their important properties are like high surface area, high electrical conductivity, and long cycle life. Second type of electrode materials is transition metal oxide, which includes various transition metal oxides like ruthenium oxide, manganese oxide, cobalt oxide, iron oxide, vanadium oxide, and they have high capacitance, multiple redox states. And next is the conducting polymers, which includes polyaniline, polypyrrole, and their properties are that we can easily synthesize this material. These are the low cost and they have high electrical conductivity, but they have disadvantages that they have limited cyclic stability and dissolution. Next part is transition metal chalcogenides and magazines. So they are metal chalcogenides like molybdenum sulfide, vanadium sulfide, nickel sulfide. And main important feature of this transition metal chalcogenide is they have 2D layered structure. They have high electrical conductivity. They have high capacitance and redox states. And next type of electrode material is hybrid electrodes. In hybrid strategy, we can combine the carbon-based materials and transition metal oxide-based electrode materials. Also, we can combine the transition metal oxide-based materials as with conducting polymer type of electrode materials. And third is we can combine the carbon-based electrode materials with magazine as well as transition metal chalcogenide. So this synergistic effect of both EDLC type and pseudocapacitor type material will give the high electrochemical performance, improved capacitance, as well as tailored structure, and as well as higher cyclic stability. So up to the hybrid electrode materials, we all know, but high entropy ceramics is a recently developed field. And why we need to go for the high entropy ceramic material? Because for carbon-based material, transition metal-based materials, conducting polymers, we are observing that these materials showing the very limited cyclic stability due to the phase due to the limited phase stability. So in order, if you want to higher cyclic stability, our electrode materials phase should be remain stable over number of cycles. So that's why people are focusing on the high entropy ceramics type of material, because these materials are multi-element type materials. They have single phase. They have higher redox activity due to the combining number of metal elements. Also, we can tune their structure, and they have high structural stability as well as capacity. So next, what is why we need to develop the new electrode materials? So for advanced energy storage application like hybrid electrical vehicles, electronics, healthcare, space, they require the electrode material with high energy density as well as high power density. So batteries are providing high energy densities and supercapacitors are providing high power density. So alone they can't meet both the needs. So our goal is combined to energy density and power density like two peas in a pod. So that we can get the advanced electrode material for our advanced energy storage application. So next is how we can enhance the energy density of the electrode material. So energy density can be defined by energy E is equal to 1/2 CV square. That is, it means energy density is directly proportional to its capacitance and electrode materials capacitance and its voltage. So how we can increase the capacitance of electrode material? That is, we can make the nanostructure type of electrode material. We can make we can develop the electrode material with high specific surface area, and we can develop the electrode material by having the high electrical conductivity, and we also focus the electrode material with high surface functional groups. So these are the various parameters for enhancing the capacitance. But how we can increase the voltage? We can increase the voltage by using the various electrolyte strategies. We can also tune the electrode material, or we can combine the two types of electrode material to enhance the voltage window of our device. And we can also design the a cell by using various separator, and we file, and also we can check the cell configuration like symmetric type or asymmetric type. So these are, when we want to increase the energy density, we must need to focus either focus on the two things for increasing the capacitance as well as voltage. So for that we are focusing the 3R strategy. 3R strategy for the developing the electrode material for advanced electrochemical application. Like, what is 3R strategy? First R is robust. Material should be we can develop the material with scalable synthesis for hybrid materials with maintaining mechanical, chemical, and thermal properties. Second, material should be reliable, ensuring stable electrochemical performance over extensive cycling. And third is resilient, which material should withstand with extreme environment condition, including temperature variation and radiation exposure. By using this 3R strategy, we have designed various electrode materials for energy storage application in extreme environment, for energy storage materials for extreme environment. So before that, first I want to discuss about what are the various strategy, what are the various materials we have developed in our lab to enhance the energy density. First, we have used the nanostructure engineering strategies to enhance the surface area of the electrode material and to get the advanced electrochemical higher energy storage performance. Second is the mixed metal strategy. Third we have used the composite formation with CNT. Also, we have used the strategy composite formation with reduced graphene oxide. We have used the elemental substitution strategy to enhance the capacitance as well as potential window. And third, we have also used the multi-component strategy. So this is the nanostructure engineering strategy. We have developed the manganese oxide electrode material by a hydrothermal method. Here we have carried out the three variations deposition temperature. We have varied the hydrothermal reaction temperature, deposition time, as well as solution concentration. And we have developed various nano architecture type manganese oxide electrode materials. Like, these are some nanoflowers like morphology, some nano argine type morphology, and we have checked its electrochemical performance. And we have got here these are the electrochemical performance of manganese oxide developed by hydrothermal method at different temperature variations. And here we have, from this CV, we have got the maximum area under curve for manganese oxide with 160 degrees Celsius, and we have got the maximum specific capacitance, which is 432 farad per gram at scan rate 5 millivolt per second. And similarly, we have also varied the deposition time of manganese oxide from 2 hours to 12 hours, and we have, and by keeping our optimizer temperature, which is 160 degrees Celsius, and we have optimized the deposition temperature, and we have got the maximum electrochemical performance for manganese oxide deposited at 8 hours. And after that, by using this optimized temperature and time, we have varied the concentration of manganese oxide precursor, and we have optimized at what precursor, what concentration of precursor we will get the maximum electrochemical performance. And we have got the maximum electrochemical performance for manganese oxide with precursor concentration 0.005 molar, and here we have got the specific capacitance up to 470 farad per gram. From here, how this deposition condition variation affects the electrochemical performance, we can see that after varying the deposition temperature and optimizing the deposition temperature, we got this much specific capacitance, and also varying this condition, we can tune the electrochemical performance of the electrode material as per our main application goal. Next, we have developed by using this optimized manganese oxide. We observed that current the manganese oxide still showing the very low capacitance and low electrochemical performance due to because manganese oxide has a low electrical conductivity, and in order to enhance its electrochemical performance, we need to combine this material with electrically conductive material. So we have made the composite of reduced manganese oxide with reduced graphene oxide, because we know that reduced graphene oxide has high surface area, high electrical conductivity, and it has various surface functional groups which can contribute in the electrochemical reaction. So we have developed the two-step strategy. First, we have to prepare the manganese oxide and reduced graphene oxide composite electrode material. First, we have deposited the manganese oxide electrode material on carbon cloth substrate by using hydrothermal method. And second, for depositing the reduced graphene oxide, first we have prepared the graphene oxide by modified hummus method, and we take out this powder, and this graphene oxide powder is used for the deposition of reduced graphene oxide on the manganese oxide electrode material. And here we have reduced the graphene oxide by using chemical reduction method, and we have developed the composite of manganese oxide and reduced graphene oxide by using two-step strategy. Here for comparison, we have here this is the XRD of carbon cloth, this is the XRD of graphene oxide, and these two are the XRD of powder. Here we are taking the XRD of powder because carbon cloth also containing the carbon, so it is very crucial to know that which peak is carbon cloth peaks and which peak is graphene oxide peak and reduced graphene oxide peaks, because these two peaks are very similar. So that's why we take the XRD of carbon cloth substrate alone and powder. So confirm that our prepared material is reduced graphene oxide, and after that we have checked the XRD of both individual manganese oxide as well as composite formation with manganese oxide and reduced graphene oxide, and we have confirmed that and our composite material from SCM also we have seen this sheet-like nature of graphene oxide deposited on the surface of manganese oxide. These SCM results confirm the formation of the manganese oxide and reduced graphene oxide electrode material. Next, we have carried out its electrochemical performance. This is the cyclic voltammetry study of the individual reduced graphene oxide, manganese oxide, and manganese reduced graphene oxide, manganese oxide composite. From CV graph, we can see that the reduced graphene oxide showing very low area under the curve, and after that manganese oxide is also showing the very low area under the curve as compared to the composite. And after adding after composition, we have got the maximum area under the curve for prepared electrode material, and we also got the maximum electrochemical performance for the prepared electrode material. So These are the stability studies, galvanostatic charge discharge studies of the prepared MnO2 RGO composite based electrode materials, and also these are the EI studies. EI studies of manganese oxide and reduced graphene oxide, individual manganese oxide, and these are the composite with reduced graphene oxide, which also shows the low charge transfer resistance when we combine the manganese oxide with reduced graphene oxide. So this study shows that how we can combine the carbon-based electrode material with transition metal oxide in order to achieve the higher electrochemical performance. So next, similarly, we have developed the cobalt oxide and reduced graphene oxide composite by using the similar method. We have deposited the cobalt oxide on the carbon cloth substrate by using hydrothermal method, and we have got the very good nanowire type nanoflower containing nanowire type morphology, and this is the graphical representation of cobalt oxide RGO composition formation, and we have varied the loading of reduced graphene oxide on cobalt oxide by varying the GO precursor content from 5 mg ml 5 mg mg per ml to 20 mg per ml, and this SEM also we can see that reduced graphene oxide flakes grown on the cobalt oxide nanowire structure. So also cyclic voltammetry study also shows that the for composite we are getting the maximum area under the curve as compared to the individual cobalt oxide, and we also got the maximum specific capacitance after making the composition with the reduced graphene oxide. So overall, this composite formation help us to understand how electrochemical performance as well as morphology changes with the change in the composition of electrode material, and this strategy we can use for the other materials to tune the performance of electrode material as per our requirement. So our next target is to develop the material with higher phase stability for extreme environment applications. So that's why we are focusing the high entropy ceramic based materials. So what are the high entropy ceramic materials? High entropy ceramics material are the multi-component element containing more than 5 metal elements. So its main structure is based on the cationic and anionic sublattices. So cationic sublattices are composed of metal elements, and anionic sublattice is composed of non-metal elements. So right now, there are various uh, types of high entropy ceramics materials are developed, like high entropy oxides, high entropy sulfides, high entropy silicides, high entropy oxyfluorides, high entropy nitrides, carbides, phosphides, and borides. And these materials are showing the very good performance as functional electrode material for supercapacitor, battery, oxygen evolution reaction, gas sensing, and thermal applications. So this is the extended family of the high entropy ceramics, and still many other fields are developing in this in the family of high entropy ceramic material. So in our group, we are designing the high entropy ceramic material by using CalFed approach. So CalFed is the CalPad. By using the CalPad, we can study the phase diagram of each materials, like each material system, like metal oxide system, metal sulfide system, metal silicide system, and also by next we are studying the machine learning, and finally we are developing the material for energy storage application in extreme environment application. So currently we are developing studying the phase diagrams of various systems by using CalPad, and we are synthesizing we are synthesizing this material by using ball milling method, and after that we are sintering these materials by using high temperature sintering systems, and we are and after that we are making the electrode materials and checking its electrochemical performance. So right now we are developing the high entropy silicide type of materials for energy storage application. And here we have chosen the refractory type of refractory elements. Because why we are choosing the refractory elements? Because these refractory elements has high thermal stability, they have high excellent electrical conductivity, and they also have high mechanical stability. So when we want to apply our electrode material for extreme environment applications like space and like for sub-zero temperature, so we need the material having these properties like high thermal stability, high electrical conductivity, high mechanical stability. So this material withstand with all the extreme conditions. So next, and also we are checking developing the silicide materials by using our conventional transition metal silicide system containing the metal elements like iron, cobalt, and nickel. So in current study, we have developed the material system from chrome vanadium silicide, chrome vanadium niobium silicides to high entropy chrome vanadium niobium molybdenum, and with titanium. And here we have varied the transition metal elements with titanium, cobalt, nickel, and ferrite. And here we are considering the stoichiometry MSI2 type of material having hexagonal crystal structure. And here we have developed this material by using the arc melting method. And after that we have checked its phase stability. And here we can see that material maintaining its hexagonal crystal structure up to by increasing up to the 5 metal systems. And currently, and after that we have checked its electrochemical performance. Currently these materials are showing the very low electrochemical performance, because when we are synthesizing the arc melting method, we are getting the very micron size material. So in order to reduce its particle size, we need to synthesize this material by using other method. But currently by our arc melting method, we are getting the, though its capacitance is very less, but this material is showing the good performance in the extreme environment condition. We have studied its electrochemical performance in the high temperature range from room temperature to up to 80 degrees Celsius, and from 0 to -30. This material showing the maintaining the good electrochemical performance. So our next target is to develop this material with high capacitance. So so that we can extend this research for novel application. Second, we are also developing the high entropy oxide materials. Why we are focusing the oxide materials? Because transition metal oxide has poor stability. They have structural and morphological deformation during the long-term cyclic stability. And so that we are developing the same, we are using the same strategy like high entropy silicide, and we are developing the high entropy oxide. So in order to get the single phase materials, and we have prepared the entropy ladder of 7 electrode systems from we have developed the material having MCO2O4 stoichiometry, and we have added the metal element up to the 7 metal elements. We have developed this material by using hydrothermal method, and we have checked its electrochemical performance. And we have observed that the material containing chrome, iron, nickel, zinc, showing the high electrochemical performance. And our next target is to check its electrochemical performance for the extreme environmental applications. So these are my current experimental results, and we are focusing these materials for the extreme environment applications. So next part is about when we are developing the electrode material, what key consideration we require to keep in mind while developing the material. First, we need to keep in mind material should have high surface area, should have high electrical conductivity, for have high electrochemical stability, high thermal stability, and high mechanical stability. These are the material consideration. But for application in industrial level, what are the socio-economic considerations? What should be the socio-economic consideration? So main consideration is availability of raw materials. So when we are designing the electron material, we must think that these raw material are available or not, easily available or not, or these are the costly or not. These materials are scalable or not. So in order to, we can go from lab scale to the industrial scale. And also next part is these materials should have reliable as well as safety. And next, it should not have the harsh impact on our environment. So while designing the material, when we consider this key material consideration as well as socio-economic consideration, and if we after that we can make the electron material, then it will be more beneficial for the our scientific community as well as for humanity also. So now the key areas of these supercapacitors are for mainly for sectors. We can use these materials mainly for portable and smart electronics, where supercapacitors give the fast charging, discharging facility. They support flexible and compact design and used as a lightweight wearable devices. And in sector is industrial, which there we can use as supercapacitor as a backup power during power outages, energy recovery in machinery, peak load leveling, and also they are used in power bus. In transportation, these are widely used materials for regenerative braking application for power boost during acceleration, extended battery life, and efficient energy source for hybrid electrical vehicle. In space, they are used for high cycle storage, instant peak power supply, and also they are used in a lightweight space missions. Bugur sir, I have more time, or I need to?
Sure, madam. 10 minutes. Sure, madam.
Thank you, sir. So first key application is portable and smart electronics. So here are the examples how supercapacitors can be used for the flexible. These are the flexible smart supercapacitors. Second one, supercapacitors are used in biomedical implants, and they are also used for the health monitoring applications. Like they are combining with sensor, and they can use as a heart rate detector. And also they are also sweet chargeable on-skin supercapacitor is developed with this type of electrode material. Second application is they are used in a renewable energy storage. They are integrated with solar PV panels. Solar PV panels, and they are combined. These are the ultra supercapacitors, and they are used to store the electrical energy for our household electrical demand. And here also supercapacitors use integrated with renewable energy sources to provide the energy storage for various uh, uh, environmental conditions, like sunny day, windy day, mixed type of day. At that time, this supercapacitor can use as a power supply source for our various application. They are also combined with the they are also used in a wind energy storage systems. Also, they are supercapacitor also used in a wind pitch control system. This is the wind pitch control system developed by Skeleton Technologies. And also third application is the transportation. This is the supercapacitor as widely used in a transportation system in hybrid electrical vehicle due to having its high power density. This is the supercapacitor powered tram, which is developed in China. Which is this tram is self-chargeable within 30 seconds, and it can go for the 4 hours of long journey. And this is the supercapacitor power charging station developed by Skeleton Technologies. So these are the various applications of supercapacitors, and there are various global key players in a supercapacitor supply chain. So supercapacitor manufacturers are Capex, Skeleton Cap, LS Material. These are and in Spell is an Indian company. Eton. These are various supercapacitor manufacturers, and for raw material providers for supercapacitor are like Graphenia, Cabot, and distributors for supercapacitor DG. These are the various supply chain in a supercapacitor industry, and our end user of this supercapacitor like Toyota, Siemens, Samsung, Apple, BMW. So this is the ecology where we can see that how supercapacitor are developed by manufacturers and how they are used by various companies. So next is the supercapacitors are also currently used for aerospace application. Here we can see the peak power demand for various space application, and on this peak power demand, this is the peak power range, and from this range we can tune the supercapacitor electron material, and we can choose for which application our supercapacitor can be used. So this is the hybrid supercapacitor is developed by European Space Agencies, and this all research work is done by the European Space Agency. This is the bank of supercapacitor, and this supercapacitor are used for the space missions like PENCO for these satellites. So from these various application, we can see that how these materials are shaping our society for various applications. And now, as Dr. Gaurav Lohar sir is already explained, the recent trends of supercapacitor is mainly developing the machine learning technique for performing the supercapacitive performance in order to reduce the experimental trial and error. So this is the very important tool to reduce our time as well as to generate the electron material with greater efficiency. So and overall, we have developed this electron material by using various advanced electrode design strategies, by using composite formation with reduced graphene oxide, element substitution, multi-component high entropy ceramics, and mixed metal oxide composite strategies. These strategies are these strategies are very important to develop the electrode material for these various applications. So this is my current research group. I am working with Professor Jongji Oke in Seoul National University of Science and Technology. And I'm thankful for the NRF for giving me brain pool fellowships. I'm also thankful to my mentor, Dr. S.P. Kulkarni sir, to providing continuous guidance in my PhD and also during my postdoc also. And I am really thankful for uh, organizers and my physics department gurus from Vinyan Mahavidyalaya. And I'm also thankful to Bugur sir to chairing the session, and I'm also thankful to all the attendees of this conference to listening my talk. Thank you, sir.
Thank you very much, Dr. Snehal Kadam madam, for a nice presentation on supercapacitor electrode material for real life electrochemical energy storage application. Now this session is open for discussion. Now this session is open for discussion. If participants have any question, they can ask to any question.
Hello, ma'am. Hello.
Please
Hello.
speak up.
I am Dr. Amar Jadhav.
Yes, sir.
Hello, ma'am. One my question regarding RGO based Yaminoto. Can you open this slide?
Yes.
Previous slide. Okay. Yeah. Here in this synthesis technique, you have used a geometry. Okay.
Yes. Yes.
But how to synthesis this geometry? Which method used for the synthesis?
Modify humor method.
Okay, modified Hilbert method. And
Yes.
we have converted GO to RGO, means
Yes, sir.
reduced graphene oxide method.
Yes.
And decorated of the MnO2.
Yes.
So in this material, in electrochemical analysis, can you open next slide? Electrochemical analysis. Here. The second row is the last diagram, electrochemical impedance spectroscopy. Okay.
Yeah.
In this graph, the MnO2 shows a less charge transport resistance. This
Yes.
RCT value is less of
Yes.
MnO2. But we have compiled with RGO, then the RCT value is goes on increasing. Why?
RCT value is not increasing. RCT here is RCT for here is RCT charge transfer resistance for with MR20. Here is composite. Here if you
Okay,
can
so
yes, and here is
okay.
RCT value of original MnO2. Here you
But
we can easily
MnO2 shows the RS value is less and RCT value is large, and RGO compile is the RS value is less. Means
RS
RCT
is
is
internal
less and
resistance. Yes, sir. Please complete your question, sir.
RS values of the RGO with MnO2 shows a larger as compared to pure pristine MnO2. Correct?
Oh, it is not completed data. If you can see, here are some data points are missing. So that's why you are seeing that the RS value is less.
Okay, but actually RGO based MnO2 shows a good result.
Yes.
Yeah. Thank you. This is the good result.
Mm.
And we
Here,
have you have used the ball milling method. Like this
no,
is
no.
the physical system. No,
For
next part.
MnO2,
Next
we are
part.
used for making the MnO2 RGO composite. For we have used the two-step method, not a ball milling method. Ball milling we have used for the
Next synthesis part. You have shown the this here previous slide.
here arc melting method is used, not a ball milling.
Okay, this is a physical method or chemical method?
Physical method.
Okay, the physical method is a cost effective.
Physical method is cost effective. It depends. Sometimes it depends. Physical method is cost effective and depends on our application purpose.
Okay, as compared to chemical method.
Yeah.
Which is best, chemical method or physical method?
So it depends on our purpose. So if you want to go for the lab scale with very short, because when we do the hydrothermal synthesis, we are getting yield very less, which is in sometimes grams and milligrams. But when you want to develop the actual electrode material for the industrial applications, you need the yield is very high. So that's why people are going for the ball milling method when we are focusing for the industrial application. If you want do your result for lab scale, go for the chemical methods. So first optimize your results by using chemical method and then focus if material showing good results, then go for the next method for the large scale development.
but method we have changed the method, then changed the result. This is the impact of the method. So we have choose the exact method for the preparation of nanomaterials.
Yeah. It depends on us which material we want to choose. Sometimes
Because we have
for
selected as a synthesis as a lab scale is a chemical
yes,
method, and as a practical application we have used a physical method. That two type of method is a different. The impact of this method is on the behavior of the charge storage and other application.
we
So
need to
how
study
to
this, sir.
yeah, okay, no problem.
Bugad sir, please conclude the session.
Now, I conclude this session. I am much grateful and thankful to Dr. Snehal L. Kadam for excellent and nice presentation on supercapacitor electrode materials for real life electrochemical energy storage application. With this presentation, Madam has given information about prestigious fellowship such as a Brainpool Fellowship as well as Global Research Fellowship. In her lecture, Madam focused on different oxide materials which is used for electrode material with its properties, and it is synthesized by hydrothermal process. Also, in her lecture, Madam not only explained various parameters for enhancing capacitor in pseudo capacitor, super capacitor in detail, but also explained advanced electrode material for real life with its application in the field of electrochemical energy storage, also power supply sources. This session has truly enriched our knowledge and understanding. Thus, the information given by Dr. Snehal Kadam is useful for researcher and budding scientist. I would like to conclude this session. I am very much thankful to participants for their silence, full listening. I hand over session to Dr. J.V. Thombre, sir. Thank you,
Okay,
sir.
thank you, sir. Thank you, thank you.
Thank you, sir.
Thank you.
sir.
We are very much grateful to Dr. S.L. Kadam madam for accepting our invitation. She is alumnus of our department. We feel very proud to be here as a capacity as a resource person. So thank you, madam. Thank you. Also, my sincere thanks goes to Dr. R.A. Bugad sir for chairing the session. Dr. R.A. Bugad sir is uh, always helping me to organize such events. Whenever I call him, he is always helping me for such events. So thank you, sir. Now I begin with the last technical session of International E-Conference with oral presentation, and the chairperson is Dr. S.N. Kadam. He is associate professor at Department of Chemistry, Dr. Ganpatrao Deshmukh Mahavidyalaya, Sangola. I request Dr. S.N. Kadam sir, please hand over the session. I hand over the session to Dr. S.N. Kadam sir. It's over to you. Kadam sir, please.
Okay, sir. Thank you. I am audible or not?
Yes, sir. You are audible.
Okay. So, first of all, I welcome all the oral presentation participants in International Lean Conference on recent trends in nanomaterials and its application 2026. All participants should note that they should complete their oral presentation within 5 minutes for each presentation. There is a time given, that is 5 minutes for each presentation. So now may I request the first participant, that is Revati J. Puja, to start their oral presentation. But Revati J. Puja, are you there? So next participant, that is Rudraya PM. Are you there? Next participant. Next participant. First participant is available or not? Revati J. Pooja. Are you there? So, third participant, Seth Sandy, MS Seth Sandy.
Hello, sir. Hello.
Yes. Yes, ma'am.
Hello, sir. This is Revati, sir. Revati Punja. Am I audible to you, sir?
Okay.
Hello, sir.
You are audible, madam.
Hello. Thank you, sir.
Ah.
I'm sharing my slides, sir.
Yes, yes. You can start your presentation.
Sir.
From there, we will count the 5 minutes. Okay.
Good afternoon, all. I'm Revati Punja, pursuing PhD in Gulbarga University, Gulbarga. Topic of my paper. Am I audible to you, sir?
Yes, you are audible, but the slides are not shared yet.
I'm sharing the slides, sir.
Yes.
I'm sharing the slides.
Shall I proceed?
Shall I proceed, sir?
Yes. Yes, yes. It is visible now.
Right, sir. Thank you, sir. Thank you very much. Good afternoon, all. I'm Revati Punja, pursuing PhD from Gulbarga University, Gulbarga. Topic of my paper is performance enhancement of dual band antenna using complementary split ring resonator. In present situation, there is a huge demand for microstrip antenna due to the rapid development of wireless communication. It plays an important role because of its properties like low cost, easy to fabricate. Metamaterials are artificial materials which are not available in nature and exhibit extraordinary properties like negative permittivity, negative permeability, and negative refractive index. Split ring resonator and complementary split ring resonator, whatever we are observing in the slide, they are commonly used in metamaterials. And split ring resonator is having, and both are having split ring resonator and complementary split ring is made up of two concentric metallic rings, each ring having a small split that is called gap placed opposite to each other. Complementary split ring resonator is the negative of the split ring resonator and which is etched from the metallic plate. And monochrome ground is in the metallic patch antenna, usually referred to as using the partial or a defective ground plane instead of full ground. It is used to increase the bandwidth and to get the dual band operations. And this is my project. In this project, the conventional antenna is designed for 5 GHz frequency and chosen as a reference antenna. FR4 epoxy substrate is used in this project, and substrate is placed at 1.6 millimeter thickness. And monopole antenna, first diagram shows the monopole antenna, which is having the ground plane of 1/4 of its wavelength. And for this project, I designed a total 3 projects. I am concentrating on second diagram, that is called when I place at the single stage CSR, that is complementary split ring resonator. And next slide shows the S11 parameter, that is return loss characteristics of all the 3 antenna, monopole antenna, when single stage CSRR is introduced and double stage CSRR is introduced. And this shows the VSWR, nothing but the voltage standing wave ratio characteristics of all the 3 antennas. And gain representation of all the 3 antennas are shown in the slides. And this is the radiation pattern of all the 3 antennas. This table summarizes all the readings. It can shows that by inclusion of metamaterial result in the substantial improvement in the antenna performance. as evidence by the reduction in the S11 parameter from -23 to -2614. This indicates much impedance matching and considerable decrease in the reflection of the incident electromagnetic waves. BSWR, that is voltage standing wave ratio, demonstrate almost perfect impedance matching, which minimize the energy loss and ensure the effective transmission of electromagnetic energy through the antenna. And we can observe there is a increase in the gain when after introducing the metamaterial, that is from 5.3 to 6.77 decibel. This confirms metamaterial after introducing the metamaterial, that is CSRR, effectiveness in the enhancement of the antenna performance. And this is the conclusion of this project, that is by 12 band antenna is used to operate efficiently for 2 different frequency bands with the single antenna. This helps to reduce the size, cost and the complexity in the wireless communication. And this table 2 shows the variation of resonant frequency, return loss, gain and bandwidth while varying the split gap. According to the table, as the gap turns smaller, it is possible to achieve the better return loss, that is at the 0.5 mm, it is reached to the 26.14 decibel. When the split gap increases, the gain also increases accordingly, and the maximum gain is obtained at the gap of 1.4 mm, at that is at 80 decibel. This is the conclusion of this table. We got the better return loss and the bandwidth when the metamaterial is introduced, and the split gap, as a split gap is increased, it is obtained, gain is obtained, maximum gain is obtained at 1.4 mm, that is the millimeter, at the 8 decibel. Thank you for my presentation. Thank you for listening all. Thank you. Hello, sir.
Hello, Kadam sir.
I concluded my presentation, sir.
Kadam sir, please conclude.
Kadam sir, unmute yourself first.
Hello, sir. आवाज थोडा कमी सांगता ना ऐकून चाललाय आवाज थोडा कमी
So, any questions from the audience?
Kadam sir, please announce another presentation. It will be better.
So now I will call next participant, oral presentation of Shinde.
Hello. Hello.
Yes.
Hello.
Yes, sir. Is it V.S. Shinde? Are you announcing V.S. Shinde?
Hello.
Hello.
Am I audible?
Yes.
Myself, MS Setsnadi. The oral presentation number 3.
Okay, sir. You can continue your presentation.
Yes, sir. Yes, sir. Just 1 second. I'll sharing my slides. Just 1 second, sir. Hello. Hello.
Sensandi sir, please start your presentation.
Sir, I'll start, sir, but somebody has shared the screen there. Kindly disable.
You have already shared your desktop. Please click on the PPT you want to share.
Yes.
Now, is it available on the screen?
Yes, your
No.
desktop is available on the
No,
screen.
no, it's not my desktop, sir. Someone has shared.
Who has shared this desktop? Please stop that. Omre sir, who has shared this?
Because somebody has shared. Therefore, I'm unable to share my. Just 1 second, sir.
Now you are on the screen. Please share.
Share your presentation.
Just 1 second.
And you are requested to conclude within 5 minutes, please.
Yeah, I will conclude. There is some technical problem here.
Hello.
Are you unable to share the PPT?
Yeah, I am unable to share the PPT.
Any technical issues there?
There is some network issues are there.
Okay, let we announce another participant. Kadam sir.
Okay.
Sir, you give me opportunity afterwards.
Okay,
Yes.
sure.
Thank you.
At the last, we will give you the chance.
Yeah. Thank you, sir. Thank you so much.
Kadam sir, announce second one.
Yes. So the next participant.
Who is next?
Next participant is V.S. Shinde. Miss V.S. Shinde, are you there?
Vidya Shinde, please present your presentation.
Yes, sir. Thank you, sir. May I audible, sir?
Yes.
Let me give 2 minutes to share my PPT. Sir, there is problem to share PPT. I don't know what is the technical issue.
Omre sir, allow him to share the PPT.
Please share your PPT. All the participants are requested to share your PPTs in the WhatsApp group. So as to I will open.
All the participants are requested to be ready with their presentation.
Kadam sir, please announce next participant.
Yes. Next participant is Meghraj P. Naik. Are you there?
Meghraj, are you here?
Meghraj P. Naik.
Yes, sir, I am here.
Please
Okay.
Yes,
start
sir.
your presentation
Please share
immediately.
your PPT.
Yes.
Oh, so several the tools. One participant can share. Who can share? All participants. You share good. त्यांना बी येत नाही त्याला काय काय आता तिकडून रिसोर्स पर्सन
Meghraj, please
Yes, sir,
start your presentation.
I'm trying to share the screen. Just give me 2 minutes time.
ask first participant how
The
to share
next
the PPT.
participant is Ganesha Acharya. Are you there, Ganesha?
Yes, sir. Yes, sir. I'm here, sir.
Okay.
Am I audible, sir?
Yes, sure.
Hello. Yes, sir.
You are audible. Please
Yes,
share your PPT and start
yes, sir.
your presentation.
Okay.
Presentation is
Shall I
ready,
start,
sir?
sir?
Yes.
Shall I start my presentation, sir?
Yes, sure.
Yes, you can share your PPT.
Sir, is it visible, sir?
Yes.
It's visible. You are sharing.
Okay, sir.
Yes.
Myself,
Yes.
Dr.
Now it's
Ganesh
visible.
Acharya.
Start your
I'm
PPT.
Associate Professor of Chemistry in Kuala University. I'm going to present a small piece of work on synthesis characterization of copper molybdate incorporated with graphene oxide hybrid nanocomposites for the decoloration of toxic textile dye and for the antibacterial activities. So now we all aware that the metal molybdate composite compounds are of very interest because of their huge applications in the sensors and catalytic and biological activities. So copper molybdate particularly has a lot of interest in the catalysis and sensor and photoanode applications. So many studies have been reported for the synthesis and characterization of these particular compounds by precipitation, hydrothermal, and flame spray methods. However, these methods are particularly costly when compared to the simple chemical methods. So we have tried to synthesis and characterize and apply these composites by the simple chemical co-precipitation method. And we know that the dyes, particularly toxic textile dyes, causes hazardous effects on human beings and animals. So to remove these dyes from the water sources is very important and essential. And also nowadays the antibacterial activities studies have been extensively studied. So therefore these are also very essential. In our procedure, we have purchased all the chemicals from Merck and SD Fine chemicals, and also we have purchased the toxic textile dye, that is deep green 474 dye from the textile industry from Molekalmur, Karnataka. So in the synthesis procedure, we have synthesized the graphene oxide by simple Hammer's method by using sulfuric acid and sodium nitrate, and we have immersed the natural graphite flakes in the sodium nitrate, and then we have added concentrated sulfuric acid slowly at a controlled condition, and also we have added oxidizing agent potassium permanganate at a controlled temperature of 20 degrees centigrade, that is 0 to 20 degrees centigrade, and then we have increased the temperature slowly, and then we have diluted it, and later we have added hydrogen peroxide to stop the reaction, so that the black colored graphite is converted to brown colored dispersant graphene oxide. Later, we have taken 0.3 grams of the prepared graphene oxide and in 10 ml water, and we have slowly heated, and we have added 5 ml dilute HCl solution to this, and then we have added hydrogen hydride at 80 degrees centigrade. Slowly, we have stirred the solution, and we have added 0.3 gram of copper molybdate and stirred the solution for 30 degrees, and then later we have added ammonium hydroxide at a pH of 7. And precipitate is obtained, and then it is ignited at a high temperature, and the obtained compound is dried. So the batch absorption studies is carried out at a wavelength of 620 nanometer for this particular dye, and we have prepared a series of solutions of different concentrations of dye, and also we have added different weights of the adsorbent that is prepared the composite. And in the antibacterial studies, we have used the specimens of Klebsiella pneumoniae and Staphylococcus aureus. These two are the species we have used for the antibacterial studies. In the instrumentation section, we have carried EDAX analysis, XRD analysis, U visible analysis, and FTIR spectroscopic analysis. In the confirmation of the formation of the graphene oxide, the 227 nanometer showed the formation of the graphene oxide in our studies, and various oxidizing oxygen containing groups, that is carbonyl group and CC groups, have been introduced at and this is confirmed at 1733 and 1621 and 1422 and 1226. That shows various oxygen containing function groups have been introduced into the compound. And the external analysis showed specific peaks at 25.98 and 22.43 and 58.34 degrees graphene oxide and incorporation of the metal composites inside the graphene. And we have carried out the EDAX analysis that showed that confirmed the formation of the incorporation of the copper and molybdenum into the graphene oxide, that shows 53.76% of carbon, 23.42% of oxygen, and copper, that is 8%. So that can be seen in this image. And the SEM analysis have been showed the flaky-like structure of the formed copper molybdate incorporated with the graphene oxide. And the dye adsorption uptake studies have been carried out, as I told you, by the addition of different concentration of the prepared composites into the different concentration of dye, and the absorption studies after and before the addition of the composite. And it has been shown that after 80 minutes of time, with the incorporation of 0.02 milligrams per liter, we have seen that there is a maximum absorption of the dye on the composite, and that shows almost 100% removal of the dye from the stock solution. And later we have carried out the antibacterial studies. We can see that here in this the positive control have been seen at 15 millimeter antibiotic with respect to
There may be technical issue. Please announce next. Next one.
Kadam sir, announce
Hello.
next.
Hello, sir. What happened? Your presentation is not audible.
Kadam sir, maybe there is a technical issue. Please announce.
There might be a
next.
network issue.
Okay,
There might
time
be a
is over
network
for
issue.
this presentation.
His connection is not stable.
I
Please
would
announce
like
another
to
one.
request next participant. That is
Suvarna Bhargande, sir.
Bhargande, Swarna, Kishan Rao.
Yes, sir.
Are you ready with the presentation?
Yes.
Okay,
Am I audible?
you may start your presentation.
Am I audible, sir?
I conclude
Yes,
my
you are
presentation,
audible.
sir.
Whether my screen is visible, sir?
Yes, you will. Now start your presentation, madam.
Yes. Good afternoon, everybody. My topic for today's presentation is metal titanides as an electrode material for supercapacitors. We know that today the energy demand is growing on, and for this we always goes with the batteries. But batteries, though they are having high energy density, they are having low power density. As we can call this as the limitation of the battery. So, and also the slow charge and discharge rate of and safety issues are also related with the battery. So we can go with the another source as the supercapacitor, which is having high power density, rapid charging discharging rate, and excellent cycling stability. So we can go with this supercapacitor. Though this supercapacitor is having low energy density issue comparison with the battery, means we can call this as the limitation. To solve this problem, we as a researcher can go with advanced electrode materials to exhibit or to enhance the power density, energy density of this supercapacitor. As Kadam ma'am said that supercapacitor, it is having majorly ADLC and pseudocapacitance. In ADLC, we can store the charges electrostatically, while in pseudocapacitor, we store the charges by Faraday redox reaction. Now, why to go for this metal titanates as a advanced electrode for the supercapacitor? Because due to outstanding chemical stability, low cost, environmental friendliness, and structural flexibility, the titanium-based oxides and titanates are attracting a lot of attention amongst the transition metal oxides. In that, titanium dioxide possesses a low capacitance and poor chemical or electrical conductivity. So we have to go with another approach to enhance the redox activity, electrical conductivity of the electrode. So we can use this TIO framework along with the transition metal oxides to enhance the energy density for the supercapacitor. So we can go with this metal titanates for this. This is the charge storage mechanism in the metal titanates. See, metal titanates are of three types: ilmenite, perovskite, and layered titanates. MTiO3, AbTiO3. These are the formulas for this. These metal titanates we can prepare by using four methods majorly: sol gel, hydrothermal, solid state, and template assisted method. We can go with the sol gel because it is a homogeneous and chemically uniform.
Madam, please come to your conclusion session.
Okay, sir. So these are the methods. We can go with the composite strategy along with the metal titanates by incorporating the graphene, carbon conducting polymers to increase or enhance the conductivity and power density. These are the standard schematic of CV and GCD behavior of the metal titanates observed. Nearly 150 to 600 is the range of supercapacitance specific value we are getting by using metal titanates. These are the some examples given in the table along with the capacitance and cycling stability. Challenges for this metal titanates, that is the low intrinsic conductivity, limited active sites. So we can work on this to enhance these parameters of metal titanates. And also, as I said, doping strategy is very good to enhance the supercapacitance or specific capacitance value increase. These are the references I use for this paper. Thank you very much for patience listening and giving me this opportunity to present the paper. Thank you very much.
Thank you, madam. The next participant, Gayatri Gogoi. Are you there, Dr. Gayatri?
Yes, sir. Actually, I am going to present myself, Dr. Manaspatim Hazarika.
Okay. May I kindly request that you should complete your presentation within 5 minutes, because all other participants are waiting there.
Okay, sir. So I am going to give my presentation on the topic ultrasonic drive-in assembly of copper nanoparticles on cellulose scaffold for enhanced bioactivity.
Okay.
The reason behind the reason behind choosing cellulose as support in the synthesis of copper nanoparticle is that cellulose surfaces have good mechanical properties. They have better thermal stability and they have high capacity for absorption of metallic particle, and they prevent the aggregation of metal nanoparticle due to interaction between the metal atom and cellulose. Different types of supports are used for the synthesis of metal nanoparticle. Without using support, after formation of nanoparticle, aggregation of metal nanoparticle occurs. So we have to use support while synthesizing metal nanoparticles. In our work, we have used modified cellulose surface for the synthesis of copper nanoparticle by using ultrasonication method. Different types of techniques are available there. The synthesized nanoparticle was utilized as catalyst for the conversion of oxime to amine, and we have also investigated the biological activity of the synthesized nanoparticle. Cellulose supported metal nanoparticles are used in various types of reaction, and we have employed it in rearrangement reaction. In this slide, I have shown how we have prepared copper nanoparticle by using modified nanocellulose surface. The cellulose that we have employed in our work, we have extracted it from Ipomia carnea plant material. I am not going into details of the synthesis procedure. These are the some analytical data, XRD, UV visible spectra, XPS, and TGA curve, which confirms the formation of copper nanoparticle and also shows that the synthesized copper nanoparticle have greater thermal stability as compared to their support. In this slide, I have shown some SAM and TAM images which confirms the formation of copper nanoparticle with average particle size of 5 to 8 nanometer. In this slide, I have shown how we have employed copper nanoparticle as catalyst for the conversion of oxime to amide under microwave irradiation. We have also studied the recyclability of the catalyst, and we have found that the catalyst can be reused with minimal loss of activity up to 5th cycle. We have investigated the biological activity of the synthesized nanoparticle against Staphylococcus aureus and E. coli, and the synthesized nanoparticle shows good biological activity. Thank you, sir, for giving me the opportunity to present my work.
Thank you. Thank you, sir.
Okay.
Now I will request next participant. That is Miss Girija.
Mahamuni. Yes, sir. Miss Girija.
Okay.
Yes.
I will
sharing
request the participant that they should come to their findings first. Okay. Skip the introduction in lesser timing and complete the presentation within 5 minutes.
Okay. I hope I'm audible and my screen is visible. Is my screen visible, sir?
Yes, yes.
Sure.
Yes. Should I start? So,
Yes.
topic of my presentation is effect of hydrothermal synthesis temperature on structural evolution and electrochemical performance of nickel foam based cobalt oxide electrodes. I am Girija Mahamuni from the Institute of Science, Homi Bhabha State University, working under the guidance of Srinivas Kulkarni, sir. So, as there was a huge discussion on why we are moving towards the supercapacitors, because the supercapacitor bridging gap between the conventional capacitor and batteries. So I'm not going deep into the introduction part. So here there are three types of supercapacitor, among which EDLCs are charge storage mechanism having electrostatically. So pseudo-capacitors store the charge electrochemically, and hybrid capacitors can store the charge both electrostatically and electrochemically. So moving towards my work, why I have chosen metal oxides and why only the cobalts? Because metal oxides have high pseudo-capacitive behavior, fast redox reaction, variable oxidation state, and good structural stability, we can say, and the tunable morphology also. And why only the cobalt? Because the cobalt having highest specific theoretical capacitance among all the periodic table metal elements, and it can show CO2 plus CO3 plus variable oxidation state. And I have chosen nickel foam as my substrate because of the 3D porous structure, high electric conductivity, high active material loading, as well as the highest flexibility involved in the nickel foam substrate. So yes, So here is the synthesis part of my particular work. Here I have synthesized 4 different electrodes, that is nickel foam based electrode, by variation of the reaction temperature, that is keeping other parameters, that is reaction time, annealing time and temperature constant, and keeping reagent constant. We have synthesized 4 different temperature variation based electrode. We have taken the temperature from 140 degrees to 170 degrees, and I'm going with the results now. So first of all, we have characterized physically those particular 4 electrodes. So here there is a graph of 2 theta versus intensity, that is X-ray diffraction graph for the checking of the crystal structure. So here we can clearly see that the peak intensity increases with increasing temperature from 140 degree to 160 degree, and the sample 160 degree shows the highest crystallinity structure. Also there is a moderate crystal sizes I have calculated here. So for the sample of 160 degree, there is a good moderate crystal size and balanced crystal structure with the good surface area, and here we can conclude that our material has been successfully synthesized. After that, I have taken the scanning electron microscopy images for all the 4 samples. So here we can clearly see that 140 degree sample is kind of agglomerated, and there are some nanowires are also present, but there is a non-uniform structure. After that, as we are increasing the temperature, the nanowires are going to form into the flower-like structure at 150 degree, and after that at 160 degree we can clearly see here that at 160 degree there is a well balanced and porous interconnected network we are getting. And after that at 170, though there is a presence of nanowires, but the structure is slightly disturbed after 160 degree Celsius temperature. After that, I have taken the EDAX. So here are the EDAX graphs. So here we can clearly see that all the 4 samples not having any impurity, and all the 4 samples have the cobalt and oxygen percent with this 160 degree Celsius temperature. Well balanced composition of cobalt and oxygen is present. After that, we have taken the electrochemical analysis like CV, GCD and EIS for the measurement of specific capacitance and measurement of rate capability. So we have taken the CV curves, that is oxidation reduction curves, for the potential window 0 to 0.65 for all the 4 samples, and scan rate we have taken from 100 millivolt to 5 millivolt. So here we can clearly see that there is a duck-like shape, which is the ideal pseudo-capacitive shape for the supercapacitive material, and we can clearly see in the results the 160 degree Celsius sample shows the highest specific capacitance from 40 millivolt per second to 5 millivolt per second. So I am getting 2339.6 farad per gram specific capacitance for 160 degree Celsius sample. After that, here there is a comparison of all the 4 samples by means of cyclic voltammetry for 5 millivolt per second, and here also we can clearly see that 160 degrees Celsius sample is stable, porous, and getting the good that is enhanced specific capacitance. After that, we have taken the galvanostatic charge discharge, and here also we are getting the highest discharge time for the sample with 160 degree Celsius temperature. And here we have comparison of the galvanostatic charge discharge sample, and here we can see that at 1 ampere per gram current density we are getting 1839 farad per gram specific capacitance. After that, we have taken the EIS spectroscopy for the analysis of the series resistance, charge transfer resistance and Weber resistance, and here also the 160 degree sample is having improved electric conductivity, better ion diffusion and low internal losses, and we can see the values of series resistance and charge transfer resistance and Weber resistance. All the 3 values are less as comparison with the other 3 sample. Here is the graph of EI spectroscopy, and it is the high resolution graph of the low frequency region.
Come to the
And
conclusion.
yes, sir, I'm going towards the conclusion. And we have taken the cyclic stability of the optimized sample, that is 160 degree Celsius temperature sample over 3000 oxidation reduction cycles, and we are getting 98% excellent retention and stability. So here I can conclude that 160 degrees Celsius temperature is the best reaction temperature to develop nickel foam based cobalt oxide electrode as an excellent candidate for supercapacitor application. These are some references, and I want to thank my mentor, Professor Srinivas Kulkarni sir, for continuous guidance and support. I sincerely want to thank my department and the Department of Physics and the Professor H.M. Pathan sir for providing me the characterization facility. And last but not the least, all my colleagues, support, family, and friends. Thank you. Thank you so much.
Thank you, madam. I would request the next participant, Ammar Yal Jadhav. Are you there? Ammar Yal Jadhav.
Yes, sir. Yes.
Yes. Kindly share your presentation.
Yes.
And try to conclude the presentation within 5 minutes. Skip the slide introductory part. Do not make it very lengthy.
Yes. Good afternoon, all of you, and chairperson. I am Dr. Amar Jadhav. I am currently working as a PPM Engineering College, Thane, and researcher at the Institute of Science, Dr. Homi Bhabha State University, Mumbai. Today, I am going to deposition different deposition time effect on the copper oxide nanomaterial growth and charge storage application. Introduction. Generally, we know that the growing demand for the sustainable energy storage application and supercapacitor is widely used because of their high power density and charging discharging mechanism, with also long cycling lifetime. But we have need low cost effective material for the synthesis of the supercapacitor. Generally, we use transition metal oxide because of their high theoretical capacitance and multiple oxidation state. But we have selected as a copper oxide because it's low cost, abundant source, and environmentally friendly. Another thing is copper oxide shows a p-type semiconductor materials and narrow band gap values 1.2 to 1.9 electron volt, and which facilitate ion transformation during the charging and discharge. And it's use a highly suitable material for the energy storage application. The research gap of this material is electrochemical charge storage performance depend on different morphological structure, crystallinity, and porosity. That's why we have used different technique and different parameters. In this work, we have changed hydrothermal. We have implied hydrothermal method for the synthesis of the copper oxide nanomaterials by using chemical method. Limited studies of the copper oxide on the deposited time for the fabrication of the binder-free electrode materials. Next objective of our work is a synthesis of 3D flower-like nanomaterials for the charge storage application. And investigate the effect of this objective is we have implied different deposition time like as a 2 hour, 4 hour, 6 hour, and 8 hour. And we have analyzed these nanomaterials using the physical and chemical method. In this physical method, we have initially confirmed this material is successfully synthesized by using structural analysis and morphological analysis. And further, we have implied electrochemical spectroscopy analysis for the charge storage application. Found that determination of the optimized condition for the maximum charge storage application. Synthesis method. Again, we have said hydrothermal method, and in this hydrothermal, we have used copper nitrate as a precursor source. And this alkaline medium is maintained by using the pH maintained by the ammonium hydroxide near to 9, which is facilitating growth of the crystalline size of the nanomaterials, and we have this chemical solution, prepared solution is kept at a 130 degrees Celsius at different deposition time, and we get finally binder-free electrodes on the stainless steel material. Here, finally simple preparation. We have got 2 hour, 4 hour, 6 hour, and 8 hour. And this sample is named as TCU1, TCU2, TCU3, and TCU4. Finally, this sample is used for the structural and electrochemical characterizations. Initially, we have done the XRD analysis for the confirmation of the materials. In this XRD pattern clearly indicates that the copper oxide material is successfully synthesized, and the indexer peaks well matched with the JCPDS card data. And we have calculated crystalline size by using Serre's formula, and we got 15.4 to 26.23 nanometer crystallite size, and it is near to the quantum dot of the copper oxide material. And highest crystallite size we got sample number 3, TCU3 means 6 hour deposited sample. Further, we have analysis, FTR analysis for the confirmation of the stretching and vibration mode of the copper and oxygen materials. And this peaks is around clearly around the 500 per centimeter. And confirm,
Jadhav sir,
again
please
confirm
conclude.
copper oxide successful synthesis. Yes, sir. Yes. In the morphological analysis, we found there the crumb-like grooming flowers on the surface of the stainless steel, and this is a binder-free porous structure of the copper oxide. We have done the chemical analysis by using CB, GCD, and EIS. In the CB analysis, we clearly indicate that the sample number 3 is deposited 6 hours. It shows a maximum specific capacitance at a lower scan rate, 5 millivolt per second, is near to 1500 farad per gram. And in this slide shows that the charging and discharging behavior of the copper oxide with also the electrochemical impedance spectroscopy. And the electrochemical impedance spectroscopy clearly indicates RES and RCT value is less as compared to other sample. Means this sample number 3 is a more effective for the charge storage application. Key finding of our work is a successfully deposition time critically influence nanostructure growth, and 4 hour deposition produce optimal electrodes. High specific capacitance, we have get 1500 farad per gram at lowest scan rate, and excellent power and energy density. Conclusion and future scope: hydrothermally synthesized copper oxide shows excellent supercapacitor materials for the supercapacitor. Binder-free architecture enhance the charge transport mechanism and loss of the charging and discharging performance. Optimized electrode can support a next generation for the energy storage application. Thank you, sir.
Okay, thank you, sir. So, Gandhi sir,
Sir.
are you there?
Yeah, I'm there.
Okay.
Yeah, I'll share my screen, sir.
Please share your presentation.
Is this
Okay,
visible,
it
sir?
is visible now. You can start your presentation, sir.
Yes, sir. Myself, MSc Sandhi, Assistant Professor, Department of Electronics, BC James College, Hubballi. My research work is on effect of FR4 dielectric thickness of performance matrix of 2.4 gigahertz and 5 gigahertz patch antennas. As I know that microstrip antennas are widely used in modern wireless communication system due to their compact size, low profile, and ease of fabrication. Among the various design parameters, the substrate height plays a very crucial role in the determining the antenna performance, such as bandwidth, resonant frequency, return loss, and gain. This presentation focuses on the was studying the comparing microstrip antenna with different substrate height to understand the effect on overall antenna performance and identify the optimal design gear. In this research, the study employs high frequency structure simulator, that is HFSS, for comprehensive performance analysis, examining the what critical parameters including S11, VSWR, bandwidth, gain, and directivity and radiation efficiency. And for this, actually, design specification for my research work is I had taken FR4 as a substrate with the dielectric material 4.4 and a thickness of 1.6 mm and 2.4 mm for operating frequency 2.4 gigahertz and 5 gigahertz. And performance metrics are analyzed, as I said, that return loss, VSWR, and bandwidth, gain, and directivity. And these are the my design antenna dimensions. I have given 2.4 and 5 gigahertz separately for thickness 1.6 and 2.4 mm thickness for dielectric constant 4.4. As we are seeing that the substrate of the different thickness not much influences the patch dimensions. They almost all remain same there. Here in this window actually has shown the S11 parameters for substrate thickness 1.6 and 2.4 for 2.4 gigahertz and 5 gigahertz macro strip patch antenna. The analysis are done somewhat like this: 2.4 frequency resonance frequency, in 2.4 thickness substrate having excellent return loss. In 5 gigahertz frequency, 2.4 mm thickness is having the best return loss there. And according to the summarizing the what result, thicker the substrate, that is 2.4 mm, performs better both frequencies with particularly low reflection losses like 5 gigahertz. For design focusing on the high frequency performance, 2.4 mm, FR4 is what recommended. And these are the what radiation patterns for all the 4 antennas with 1.6 and 2.4 mm thickness for 2.4 gigahertz and 5 gigahertz frequencies. And a little that's what I'll give you what brief analysis of the pattern there. For 1.6 thickness, the main lobe strong radiation broadside direction. For 2.4 thickness, main lobe is what similar broadside direction as 1.66, and the key insights are 2.4 mm thickness slightly increases side lobes but retains the broadside performance. And these are the what gain analysis of all 4 antennas. And if you just go through the what the comparison there, the higher the thickness of the substrate provide the better return loss, higher gain, and wider bandwidth here. And these are the some graphical analysis of the gain and directivity and bandwidth and VSWR. And the result these are the what fabricated antenna of my research work. And first 2 are the what 1.66 thickness microstrip patch antenna. Second 2 are the 2.4 mm substrate thickness of the what microstrip antenna. And the very quick conclusion of my research work is the antenna generally performs better at the what 5 gigahertz frequency compared to 2.4 gigahertz frequency, exhibiting higher gain and directivity and bandwidth. This likely to due to the what shorter wavelength 5 gigahertz, allowing the more efficient radiation. And the impact of the substrate thickness for both frequencies 2.4 mm substrate thickness is generally result superior performance. This is evident that the higher gain directivity, bandwidth, as well as what for 2.4 mm thickness. Okay, this is my presentation. Thank you for giving opportunity to present, sir. Thank you. Thank you so much.
Thank you, sir.
Thank you,
Thank you very much. I think all the participants are over now. Is there any participant which remains again?
Kadam sir, please conclude.
Okay. So now I declare that the oral presentation session is over now. I am very thankful to all the presentation participants, and I have also thankful to the organizing committee for giving me the opportunity for chairing the session. Now I will over the session to Dr. Khambri sir.
Thank you, sir. Thank you for chairing the session. All the oral presentators have presented their presentation in nice manner. So on behalf of our organizing committee, I congratulate them, all of them. So thank you, sir. Thank you very much. Now the next session will be the valedictory session, and the session coordinator is Dr. S.S. Dasade sir. He is coordinator IQSC. So I hand over the session to Dr. S.S. Dasade sir. Sir, it's over to you.
Okay, thank you, sir. Thank you. Now over to the valedictory session. May I audible to you all?
Yes, sir. It's audible.
सांगोला तालुका शेतकरी शिक्षण प्रसार मंडळ सांगोला डॉक्टर गणपतराव देशमुख महाविद्यालय सांगोला 2 days international conference on recent trends in nanomaterials and its application RTNA 2026. Now respected chief guest, delegates, esteemed speaker, honorable dignitaries, faculty members, research and dear participants. As we gather here for the valedictory session of 2-day international conference, it gives me immense pleasure to reflect upon the enriching academic journey we have experienced together for these 2 days. Over the 2 past days, we have gained valuable insights, thought-provoking discussions, innovative research, presentation, and meaningful academic exchange. The conference has truly served a vibrant platform for sharing knowledge and also of fostering collaboration and strengthening the global academic networks. The enthusiastic participation of scholars and experts from diverse institutions and regions has added immense value to this international event. Today's valedictory session marks not just the formal conclusion of this conference, but also beginning of the new ideas and also the collaboration and research pursuit that will continue beyond these 2 days. With this note, I introduce Dr. V.B. Patil sir, President of this valedictory session. Dr. Vikas Patil is distinguished academician and scientist. Currently, he is serving as Director of Innovation and Incubation and Linkage Center, Punyashlok Ailedev Holkar, Solapur University, Solapur. He is Director of School of Physical Education, School of Physical Sciences at the same university. Here he also holds the position of Professor and Head, Department of Electronic Sciences. He has published near about more than 205 research papers in Scopus industry international journals such as Elsewhere, Springer, RESC, and all reputed journals. He is having amazing H index of 60 and he is having the citations of 9,744. With this excellency, his cumulative impact factor is 724. He has also contributed to more than 100 conference publications. His authorship has, he has authored 8 research monographs. Also, he has published 5 textbooks and 11 book chapters with global reputed publishers such as Elsewhere, Springer, and NOAA. As a principal investigator, Dr. Patil sir has 19 major research projects with cumulative research grant of near about 4.2 crores, which they have funded by UGC, DST, CSR, BNS, DRDO, RGST, and BRAC. His international collaborations span institutions in Malaysia, South Korea, Taiwan, China, Saudi Arabia, and Spain. Dr. Patil sir has 5 granted patents and 3 recently he has filed, including innovations in ammonia and NO2 gas sensors, nanoparticle synthesis, soil moisture sensors, and extraction, some of the extraction methods. He also transferred key technologies to the industry and particularly in the area of sensor development. In his academic career, he has served as acting Vice Chancellor, Pro Vice Chancellor, Registrar, IQSC Coordinator, Director of R&D, Punyashlok Ailedev Holkar, Solapur University. His contribution have recognized several best awards. He is honored by Best Teacher Award, International Innovation and Research Excellence Award, and World Top 2% Scientist in the Physics. With this, I welcome Dr. Patil sir in this event, valedictory session. Now, the chief guest of our this function is Dr. Srinivas Kulkarni. He is the director, the Institute of Science, Mumbai, Homi Bhabha State University, Mumbai. He has published more than 105 5 international papers in reputed journals like Springer, elsewhere, RAC, and also in one of in reputed journals. His impact factor is his cumulative impact factor is 610. He is having H index of 34 and H10 index of 93. He is also honored by Best Research Paper Award, also honored by Young Scientist Project Award, which is funded by DST New Delhi 2005. He is also honored by UGC Postdoctoral Fellowship 2010. He is also honored by Mentor of DST Inspire. Under his guidance, 4 PhD students were completed their PhD work, and 5 of them they are to be working. His research projects, he has completed 6 research projects from DST, UGC, DAE, and 2 research projects were ongoing. They are from BRNS and UGC. With this, I welcome Dr. S.B. Kulkarni to the valedictory session of this international conference. I formally begin the valedictory session and request everyone to actively participate as we move ahead with the concluding ceremony. For this, I would like to invite Dr. J.V. Thomre, convener of this conference, for conference overview. Dr. Jagannath Thomre, over to you.
Okay, thank you, sir. Ladies and gentlemen, good afternoon to everyone. We are in the valedictory session of RTNA 2026. Department of Physics, in collaboration with IQSC of Dr. Ganpatrao Deshmukh Mahavidyalaya, Sangola, has successfully organized an international e-conference on recent trends in nanomaterials and its applications 2026. This e-conference is sponsored by Punyashlok Ahilyadevi Holkar, Solapur University, Solapur. For this conference, more than 300 participants have registered for the conference. Near about 20 participants are from abroad. More than 30 participants are from other than Maharashtra state. RTNA 2026 has planned in 2 days with 5 technical sessions. The resource persons were delivered lectures from various topics related to synthesis and applications of nanomaterials. RTNA 2026 was inaugurated with the keynote speaker, Professor R.K. Kamath sir. He is Vice Chancellor at Dr. Homi Bhabha State University, Mumbai. The first technical session was invited talk of Dr. P.G. Parale. He is from Hiroshima University, Japan. He has explained various types of the synthesis methods of aerosols. Also, he explained different applications of aerosols in nanotechnology. The second invited talk was given by Professor R.S. Mane sir. He is senior professor at Department of Physics, Swami Ramanand Tirth, Marathwada University, Nanded. He explained various nanomaterials and its synthesis methods. He had focused on current trends of the nanomaterials in the numerous applications. Second day of the conference was started with the invited talk delivered by Dr. Gaurav Lohar from LBS College, Satara. Dr. Lohar has given talk on machine learning and energy storage technology. The second session of the second day was invited talk of Dr. S.L. Kadam from Seoul National University of Science and Technology, South Korea. Dr. Kadam shared information about the Brainpool Fellowship to the young researchers. Also, she focused on various energy storage materials designing, that is real life applications of supercapacitors. The last session was of oral presentations. 10 participants have shared their research work as an oral presentation. Also, we are publishing conference proceeding. We received more than 25 research articles for the same. With this, I conclude the overview of the conference. We are very much grateful to Punyashlok Ahilyadevi Holkar, Solapur University, Solapur, for sponsoring e-conference, that is RTNA 2026. Also, I am grateful to our Sangola Taluka Shetkari Shikshan Prasarak Mandal Sangola for motivating me to organize RTNA 2026. Also, my sincere thanks goes to my colleagues for making this event successful. I hope you enjoyed RTNA 2026. I apologize to participants for their inconvenience, if any, during RTNA 2026. Thank you. Thank you very much. Thank you, sir.
Thank you, Thomre sir, for your conference overview. Now it is time to collect the feedback from participants. Participants are requested to share their thoughts over this platform. Please. Any of us from the participants?
Sir, I'll share the feedback.
Yes, sure.
Yeah. So, honorable dignitaries, chief guest Professor Srinivas Kulkarni sir, President Professor Vikas Patil sir, all respected other professors, and my dear friends. Thank you for this beautiful opportunity to give me the feedback of this conference. This was a very useful and informative e-conference that provides the valuable knowledge, especially to the students from the rural areas like Sangola. The session were very organized and highly enriching. The keynote addressed by the Vice Chancellor of my university, Honorable Dr. Rajneesh Kamath sir, was truly encouraging and insightful. His guidance motivated young researchers like us to aim higher in our academic journey. The invited talk by Dr. Lohar sir on recent trends in the nanomaterial and future opportunities was really excellent and very informative. The session by Dr. Snehal Kadam madam from South Korea was also very interesting and inspiring. It was a very proud and lucky moment for me to listen my super senior sharing her research experience at an international level. All the invited talks, keynote speakers delivered high quality and knowledgeable presentations. I sincerely thank the organizers for providing me the opportunity for presenting my work, and overall it was really a wonderful and enthusiastic learning experience and a memorable academic event. Thank you. Thank you so much.
Anyone? Any of us from participants? Okay, thank you, Girija ma'am, for your thoughts for this conference. Now I would like to invite chief guest of this valedictory function, Dr. S.B. Kulkarni from Homi Bhabha State University, Mumbai, for his valedictory address. Dr. Kulkarni sir, over to you.
Hello, good afternoon to all. Am I audible?
Yes, sure, you are audible.
The president of today's function, Dr. Professor Vikas Patil, principal of this college, Dr. Mullah, the faculty of Physics department, convener, coordinator, secretary of this international e-conference, and participants. From yesterday, I have attended few sessions of this conference. At the outset, I congratulate the team of this Physics department and the officers or principals, president of this college for organizing such a event, e-conference, international conference at this college, because this is a nice opportunity and forum for the researchers working particularly in various research labs as well as colleges. As Professor Thomre mentioned that 20 participants were from abroad, as well as from other states also there are few participants. I have seen the presentations made by them also. And many participants are also from the colleges in rural areas. So this conference has provided the best platform for researchers to share their ideas, to listen the lectures of various eminent personalities. I also want to congratulate this college because many students, past students from this college are not only obtaining their graduation, post-graduation, but they are doing PhDs also, as well as now they are working abroad also. The best example is Dr. Snehal Kadam, Dr. Ringole, Dr. Sagar Mane. Many students are now working in well-reputed laboratories of the world. So this is the prestigious and proud moment for the college and the faculty of the department. So I want to connect this idea because this conference was the center theme of this conference was the nanomaterials. And I wish to connect this development in nanomaterials towards the Vikasit Bharat, which is the dream of not only our Prime Minister, but it is the dream of the every person, citizen of the India. So just because I will not going to repeat, we have listened many speakers in past few days, 2 days. So just I want to highlight few things. Through this small slideshow presentation. This screen is visible to you?
Yes, sir. Yes, sir.
Yeah.
Yes.
So just role of nanotechnology in Vikasit Bharat 2047. So as you have listened from these various lectures, because most of the lectures are on the energy storage, particularly then sensors, then use of nanomaterials in agriculture. So nanotechnology is a critical drive for achieving a Vikasit Bharat by 2047, offering a transformative solutions in healthcare, agriculture, energy, and environment sustainability. The climate change is also an important parameter in that. By enabling the manipulation of materials at nano level, atomic scale, it fosters self-reliance in high-tech sectors such as semiconductor manufacturing, advanced diagnostic, and sustainable high-efficiency energy systems. As we are aware that recently in Davos, many agreements were made for the development of semiconductor industry in India, because still we are lacking in the manufacturing of these semiconductor chips and other things. And you might be aware, before 3-4 years there was lot of crunch in the automobile industry, because due to that COVID period and other things, the chips were not available from China and other countries. So there was a lot of crunch or shortage of that chips in semiconductor chips in industry and in automobile sector particularly. And that's why our Prime Minister and our government, both central government and Maharashtra government, had decided to go towards the exhaustive use of nanotechnology in the development of these semiconductor chips. And now in Gujarat as well as in Maharashtra, the factories are commissioning the semiconductor plants. So today we know that towards the Vikasit Bharat, we are 5th largest economy in the world. And in next few years, we are trying to become the 3rd largest economy as GDP crosses US 5 trillion economy. And our objective is to achieve the Vikasit Bharat or completely developed nation, the top nation in the world in 2047. And towards this conference is the first step. Such similar conferences will be the first step to achieve the development in the field of nanomaterials and nanotechnology, and that journey will end at the Vikasit Bharat 2047. So as you know from various lectures, nanotechnology applications are now in every sector, right from energy, medicines, drug delivery, nano biotechnology, nano devices, optical engineering, defense and securities, bioengineering, cosmetics, nano fabrics. So a lot of applications are there, and through 2 days different sessions you might have aware regarding this, particularly the area like Sangola where the fruit industry or cotton industry is dominating. There the applications of nanotechnology in that field may be very, very useful, because this area is famous for pomegranate as well as the cotton industry also, grapes nearby Sangola. So the nano fertilizers or use of drone technology for the sprinkling water or monitoring the things, this technology will be definitely useful for that area. So the vision of Vikasit Bharat 2047 is develop self-reliant India, technological sovereignty, sustainable economic growth, and global innovation leadership. So if we go ahead or if we develop ourselves in the field of science and technology, and particularly in the field of nanomaterials and nanotechnology, definitely we will achieve this place. So I will skip few slides because already you are familiar with these things. So particularly in solar energy, energy storage, and hydrogen economy, this development in the field of nanomaterials and nanotechnology will be definitely useful. Right now, most of the laboratories in the India, the researchers are working on this to develop the indigenous fuel cells, indigenous supercapacitors, indigenous batteries, and lot of young scientists, young researchers are coming ahead with the new startups in the field of nanomaterials and nanotechnology. Even in healthcare, this drug delivery, particularly targeted drug delivery, gold nanoparticle diagnosis, mRNA nano carriers, there is a lot of scope with the help of advanced technologies. Similarly, in the field of agriculture, nano urea, slow release of fertilizers, precision farmings, some sensors for the agriculture purpose, humidity sensor, water sensor, all these sensors are useful, temperature sensors. If we could develop these sensors indigenously, that will be the boost to our agriculture area as well as the economy. Even in water purification, because it is the right to get the pure water. Every citizen has this right, and right now we know that we are getting the each water sources are getting contaminated. So the research with the help of nanomaterials and nanotechnology is required in this field to get the clean drinking water. For that purpose, the different types of membranes, different types of filters with the help of nanotechnology is also in high demand. Similarly, semiconductor mission, already I have discussed. Even in defense, we are developing the different composites, nanocomposites, radar absorbing materials, high temperature nanoceramics. The material stands at the terahertz frequency. Such materials are the requirement of our defense for the advanced purpose. Similarly, this will give the economic impact, because if we develop the indigenous technology, lot of dollars will be saved and the economic growth of our nation will take place. MSME innovations are playing the important role in this field. Even our government is not behind these things. They are supporting Department of Science and Technology, is giving various projects, various schemes under the Nano Mission, Centers of Excellence, Infrastructure Development, integration with the national missions like Make in India. We know that this program is going very well. Then Green Hydrogen Mission, Semiconductor Mission, Startup India, all these schemes are there. And with the help of all these schemes, lot of starters are coming, particularly in this field of nanomaterials and nano technology. The main challenge in this, our research is okay. We are doing the research at laboratory level. We are making some demo type or prototype models. But the main challenge in front of us is the technology transfer. Right from lab to industry, that transformation is required, and we have to work hard in that case. And particularly our young students working abroad, they may help in this transferring of technology from laboratory to industry. It is an important part, and definitely in coming years we have to work, we must have to work on this. Similarly, some policies, nano mission, funding ecosystem, global collaboration, these are the expectation from the government agencies or industry to sponsor the projects, to encourage our researchers to develop these things. Then sustainability and net zero, lot of discussion is already made on this. So for young researchers or the graduate, postgraduate student, the areas like nanomaterials, thin films and energy devices is useful for them to enter in this field, to do their projects, to do their PhDs, to do their postdocs, and come back to the India to help in the development of India. So if we collectively do the effort, definitely future outlook will be Vikasit Bharat at 2047. India is a global nanotech hub, and export-oriented deep tech economy is possible with the collective efforts from all these Indians. So in conclusion, nanotechnology is the foundational technology for that, catalyst for Vikasit Bharat, and science-driven national transformation. So with this, I will conclude my talk, and I am thankful for organizers for giving me this opportunity to address the gathering at the concluding session of this conference. Thank you very much.
Thank you so much, sir, for your informative speech on Viksit Bharat. I am grateful and thankful to your speech on nanotechnology also, and your speech was too much informative for our participants. Thank you, sir. Thank you so much. Now I would like to invite Professor Dr. V. Patil, Director, School of Physical Science, Deshmukh Holkar, Solapur University, Solapur, for presidential remark. Patil sir, over to you.
For the well-deserved function of the International Conference on Recent Trends in Nanomaterials and Applications, organized by Department of Physics and Internal Quality Assurance Cell of Dr. Ganpatrao, Deshmukh, Mahavidyalaya, Sangola, and this conference is sponsored by Deshmukh, Solapur, and Solapur. For this conference, chief guest, Professor S.B. Kulkarni, sir, Director Institute of Science, Baba State University, Mumbai. Principal of the college, Professor Molani, sir, IQC Director, and my friend, Professor Dasade, sir, convener of this conference, Dr. Jagannath Thomre, sir, Head of Department, Dr. Navle, sir, all the organizing team, resource person, delegates, and dear participant friends. At the outset, I am very much thankful to give my valedictory address on this occasion. So it gives me an immense pleasure to preside this weltering function. And I'm very thankful to organizers for inviting me for this function. So this international conference organized this college, that is Dr. Dasade sir, she has mentioned that in his introduction, that is over 300 students participated in this event. So every success of any conference, it measures in terms of the participation of students as well as the innovative talks by the scholar research presented during this conference. And I feel that the success of this conference, it is included in that. So during this conference, that is various lectures delivered by research scholars, eminent research scholars from Japan, from South Korea. So on gas sensor, supercapacitor, as well as the photocatalytic applications and new things basically coming in the supercapacitor, it is the DFT. So actually these technologies are very, very important as far as the present era is concerned. You know that present era is of research, innovation and development. In earlier days, we are saying research and development, but nowadays, the government is also emphasizing on research, innovation and development. And government also providing support, encouraging the students as well as the researchers to develop their facilities, that is indigenous facilities. And just Professor Kulkarni sir has mentioned that is we are looking to the Vikasit Bharat 2047. This is the dream of our Honorable Prime Minister Narendra Modi. And on this occasion, I urge all the research scholars, they have attended this conference. That is, don't you rely or you put your research in your lab. You convert your research into into the technology and transfer to the industry. Basically, you will get the income from that. So this is basically present era. You have to convert your research into the technology, and you first that is protect your research in terms of the IPR, maybe the patent, maybe a copyright, maybe a design. So I express my sincere gratitude to Chief Guest Professor S.B. Kulkarni sir. He has given very good thoughts regarding the Vikasit Bharat and present the policies of government of India regarding research, innovation and development with concern Vikasit Bharat 2047. I appreciate the efforts by the IQC Director, Dr. Dasade sir, Convener, Dr. Jagannath Thomre sir, head, and all organizing team for organizing such a treat. Basically, this is the scientific treat, and it is available at a rural area. There is like the college at Dr. Ganpatrao Deshmukh, Mahavidyalaya, Sangola. So I appreciate the efforts of all organizing committee. Also, this conference is supported by our university, that is Pune Shlok Adolka Solapur University, Solapur. Okay, so as well as some sponsors are there. So I congratulate them also. And this conference is possible due to the support of university and these sponsors. I congratulate all the participants and all the organizers for making this conference a grand success, because from the participants, more than 300 participants and more than 10 invited talks, it enrich the content regards to the topic considered for discussion during this RT International recent trends in nanomaterials and the application. I feel that it is up as far as the present concern. So I'm confident that the deliberations and interactions through the oral presentations or poster presentations or the invited talks during these sessions will inspire all the students, researchers, and it will help to collaborate in the field of the nanometers, maybe gas sensors, supercapacitors, or DFT. So with this word, I wish all the participants continued success in their academic and research endeavors and a safe journey back home. Thank you very much. Thank you, organizer. Thank you.
Okay, thank you, sir, for your wonderful presidential remark. Now we will move to the vote of thanks. May I request head Dr. B.B. Pule sir to pay the vote of thanks to this valedictory section.
Good afternoon, everyone. I am audible. Am I audible?
Yes, sir, you are audible.
Okay. Thank you. Respected chief guest of this valedictory function, Professor S.B. Kulkarni sir from Dr. Homi Baba State University, Mumbai. Respected President of this function, Honorable Dr. V.B. Patil, Director, School of Physical Sciences, Punyashlok Ahilyabai Holkar, Solapur University, Solapur. Ladies and gentlemen, it is a great honor to propose the vote of thanks for this valedictory function of International E-Conference held on recent trends in nanomaterials and its applications, RTNA 2026. We are grateful to chief guest of this function, Dr. S.B. Kulkarni sir, for gracing us their presence and sharing invaluable insights. Our special thanks to the president of this function, Honorable Dr. V.B. Patil sir, for sharing their valuable time and guidance. A big thanks to the president of Sangola Taluka Shetkari Shikshan Prasarak Mandal Sangola, Honorable Dr. Aniketji Deshmukh, Secretary Honorable Vittalrauji Shinde, all directors and Principal Dr. Mulani for their support to organize this event. I must mention our deep sense of appreciation for the convener Dr. Thomre JV and his organizing committee, IQAC coordinator Dr. S.S. Dasade sir, and technical staff for their efforts behind to make this event a success. Finally, a big thanks to all participants, researchers, resource persons, the chairpersons for making this event a success. Thank you all once again.
Okay, thank you.
Thank you, sir. Okay, thank you.
Thank you. Thomre sir, any announcement for the participants regarding the certificates and all these things? Feedback?
There is some announcement related to certificates. All the participants are requested to fill the feedback form, which will be shared in the WhatsApp group. After filling this form, you will get the certificate. This certificate will be this certificate will be received in your email directly. So thank you. If you have any queries, any problem, you may ask in WhatsApp group. WhatsApp group is open to all. Thank you, sir.